runtime. Then we have the shared code. So in this case, a code which is being run, standard code, can be run throughout. Android can be run through iOS. So if you look at this, it's being extended to the end here, meaning when a standard code is written, it can be shared throughout all the platforms here. So we have the C#, which is for the UI. Then I have. Let me move to the next screen where everything is being explained. I'm not going to talk or go into details with this because we are just dealing with this in the few 30 minutes. Then we move on to our demo. So here, that's what I'm going to do. I'm going to Xamarin. So I have the Xamarin definition here, which states Xamarin is primarily a platform for developing mobile applications. So Android, iOS, Windows, and Mac OS using C#. Okay. So the Android is a platform we are going to target actually. Then Xamarin.Android is a framework. Then mono.net runtime. So to build platform, to build across or cross-platform applications, okay, to run on both. So the magic is mono.runtime. That's what stands between the C#. We are building Android applications, so it has to stand between to convert or translate to the platform we are going to build on. To translate the C# to the platform we want to run our application on. So C#, that's the entire application. So the entire application is written in C#. That's the code we are going to use. Then Android XML defines the user interface of the application. Yeah, so someone will ask, why C# best language for mobile development? I just picked few. I've provided a link from that. I've provided the link at the end of my slide. You can read more. It's on the, I think it's on the Microsoft Xamarin blog site here. So it's the reliability of C#. That's its type safety. So C# actually is one of the languages that prevent types error. Okay, so with C#, it helps developers it makes it faster and easier for programmers to detect and isolate bugs at compile time. So whilst you compile, you get your bugs, then you fix them. It makes it easy, and you are able to do all these things very quickly. And running your project in C# is the easiest way, and most developers really love to use that. So fast execution on Android, C# performs better than Java. I didn't say that. Developers can confirm that. Yes, I didn't actually say that, but developers can confirm that. It performs better than Java, both because of language design choices. Okay, support the value types, real generic types, non-virtual method defaults, and the more mature mono runtime. Okay, so easy to adapt. C# is really easy to adapt, extremely easy language to learn. I learned this Android development with C# within just a single day. Should I say a single day? I just learned this in a single day, and it's really easy to work with. I won't lie about that. The language is really easy to learn, especially for developers who are already familiar with the principles of object-oriented programming. And its portability makes it the best language for mobile development, because between Windows, iOS, and Android, your C# code can run on over 2.2 billion devices. That's awesome. And beyond mobile, C# is highly portable in a wide range of environments across the spectrum of mobile, embedded, desktop, and server computing. This is so awesome. You've not seen anything yet. There is a whole lot about C# you are going to learn. And I really appreciate what the .NET community is doing. So we are going to set up. I won't set up because I've done that already, but for attendees and participants to go through, you have to install the .NET SDK. So that's the .NET 5 that is just being launched. So you install Visual Studio ID, that's the ID that you're going to use for your development, and you have to enable Xamarin to include to include it in your installation, which includes the Android SDK. So I have the link here for Visual Studio if you want to download, or you can just check that on Bing. You can just search it on Bing to download the Visual Studio. All right, so before we go into the COVID-19 Fact app, which I will take you through, but before we go there, what I want to do is to take you through on how to let me work on this to take you through on how to create your first Android application in the Visual Studio. Okay, so let me open my Visual Studio. Okay. All right, so I'm sorry for the delay. Okay, so my Visual Studio is open. As a first time I'm going to develop. As you are going to create your first project, you click on this particular one which says create a new project. Okay, so let's create a new project. All right, so one awesome thing, you don't need to look for what you are looking for, or you don't need to go through all this to look for.
Hey, it looks like we might have lost Shadrach just for a minute. We'll see if we can get him back on. In the meantime,
Okay, so
yes, excellent. We lost you there just for a minute. Take it away.
okay, so that's okay. Is that okay? Can I move on?
Yes, you can. Yes, you're good to go. We got you
Sure.
back.
All right. Awesome. Awesome. Okay, so you give your project, your Android project a name. That's Hello World. So we are just giving it Hello World. And then you just leave everything here. Then you create your new project. Okay. So here we have templates. You have single view app, navigation, drawer app, tabbed app, and we are going to create a blank application. So you select the blank application. You have your minimum Android version here. So our minimum Android version, we use Lollipop 5.0. Then you just go on to create your first project. Just some few seconds. Yes. Some few seconds. It has to load the other files. Yeah. All right. Awesome. 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 So we have a new project opened here. You can see this your main activity.cs. This where the entire process is being taken place. Let me done this. Okay, so we have your asset. You have your assets here. You have your resources, the drawable where your images are being kept, your layout. So this is your activity layout. That's where your interface. I think the app is still loading. Yep, I think it's still loading. All right, so the activity main defines your interface. Yes, so this where you have your interface or your UI. So let's see if this will open shortly. So I can show you something. So it's just an amazing something. Just the same thing you have in the other platform that you use in developing your Android apps. Um, it's just an amazing that you have the same thing here. You can develop your applications here as well, and you can even do more here. So this our application. You can see the UI, the interface of the application here. You can so let's do something like hello world. Let's create a test view. Yeah, let's create a test view. So we have a test view. Okay, then match parents. Then wrap content. Okay, so let's have Android tests. Okay, let's have hello world. So we have hello world. Awesome. I hope you guys can see it. Whilst I'm inputting everything, it's just taking place here. Quite simple and so interesting. So yes, it's really interesting, and it's very simple. I know you are going to love it. So let's center align this. So Android TST align. So let's put this in center. Awesome. So you have this in center align. Let's have it in the. So right now, let's put this hello world in the middle of the application. Okay, so I'm putting this hello world in the middle of application. So Android again, and this time around I go layout. Yes, so layout center in parent. Yeah. So this is true. All right, this is awesome. So you can add more stuff to it. One interesting thing about it is if you don't know anything, if you don't even know anything, and this is your first time working with Visual Studio in creating your Android app, if you don't know anything at all you need is think about something. Okay, so I want my hello world to be somewhere in the corner there. Okay, so in case you want it to be in somewhere in the corner there, then you type Android. So you just begin your Android, then you realize you are getting the snippets, which actually gives you samples of whatever you need. So as soon as you start typing, you can all see here, as soon as you start typing, it starts popping up. Anything you need, you just fix it in there. So if you are a first timer, you don't need to worry at all. You don't need to get bothered. This is something which is very easy and awesome to use as well. So we have our hello world ready here. Let's try and run it in our emulator. Okay, so it's getting it installed in emulator. Then we can give it a try and see how it looks like. So after this, we just move straight away to the COVID Fast app, and just go and have a look at it. how it's like. It's something I built within a day, something simple. And I know most of you are going to like it. I will push it on GitHub as well. So in case you want to give it a try, you want to change some things in it, why not? You feel free and work with it. So whilst this running, we can just go and take a look at that. Since we don't have much time, we just go and have 10 minutes look at that. So this is it. Something simple I created in the with .NET I created in the Visual Studio. You can all have a look at it. It's very simple. So I'm just going to brush you through whatever I have on the interface here or the UI, whatever I have here. I'm just going to brush you through. So this is the activity main. I'm going to brush you through everything I have here. So I have the test view here, which you can all see here. So as soon as I click on, it just points here. You can all see that here. And the test view, I gave it an ID, which is test fact. I gave it an ID. Then I did this here, the layout, where I fixed it in the middle here. So I'm actually using relative layout. So in relative layout, what I do is I just call, if you look here, I just call the layout that I want this image to be on top of the text fact. So this is the text fact. So what happened is when I change the position, no matter the position I change, it's still going to be the same. If I move this down, if I move it somewhere here, let's give it a try. Okay, let me take it out and fix it here. So you realize it's still there. It doesn't change. But if in case you use linear layout, it's going to change. But in relative layout, it doesn't change because I've called that it should be above the text fact. So it's not going to change its position because it's still going to be on the text fact. And so I have to put in the logo. You can see the logo in here as well. The logo is in here, and it has a drag and drop function. So this logo can be dragged from your desktop and you can just drop it here. Okay. So I have the logo here. I just give it a margin. Then this where I arranged it. I make it stay on top of the text fact. Okay. So this is the logo. This is what I call the logo. The logo file name is COVID. Then yes. So I have a button here as well. You can see the button here as I clicked on it shows here as well. So I have the button here with also an ID as well. Then also I have to arrange the button to give it a fixed position, which I did here. So Android layout below, then I have to bring in the ID for wherever I want it, or the particular the particular interface or the particular UI that I want it to be around under. So you can see it here, TST or test fact. So it's actually under the test fact. So no matter wherever I place this, if I place it on top, it's still going to be under this. Okay, it doesn't mean if I change it here, it's going to be on top of this, but it's still going to be under because I've declared that here. Okay. So yes, and with this, I've linked it to a string. Okay, so I have a string here. When you go to strings, okay, yes. So I have my strings here. So it's linked. So this string fact test has this string, which is click button to learn more. So if you go to the activity main, the fact test, this particular one, you will see click button to learn more. Okay, so it's linked here. This is it, Android test. Okay, so fact test, and in it is click this button to learn new fact. Okay, to learn new fact. Yeah, sorry. All right, so the same thing applies to all this one. This also have the same thing with this button link. Yes, with this same link. Same thing. So here is our application name. So you can change the application name also here as well. Yeah. So this is just there in order not to have so much text here. You won't have so much text here, but you reference everything in the string. Okay. Then this is where the action take place. This is where all the work take place. So when you have this, your layout ready, you know, it doesn't have anything behind. It doesn't run. There's nothing that goes on there. You won't have anything running there. You just have this interface designed. Nothing is in there. It won't work. If you click on, nothing will work. So what you have to do is to put the code behind that to work. Okay. So if you look at this, everything is C#. Everything is C#. So I copied this from World Health Organization site. These are strings, list of strings I copied from the World Health Organization site, and I just linked it to facts. So that's what I have here. Then I created buttons. I created buttons for them. So I have my private button because I'm not going to use it anywhere again. I'm just going to use it to do my test, and that's all. So I have my private button. I name it BTN fact. I have my private test view. So I also give that TST fact. Then I have to direct my button. So right now I have to give my button something to do, or I have to direct it to something that when you click on, what should the button be linked to? What should this declaration be linked to? So that's what I did here. So BTN fact is equal. So you have this here. So I'm directing it to find view by ID. Okay, so this is the button find view by ID. Then where can I get the ID? So resource.id dot btn fact. Okay, so this, if you remember, btn fact. Yes. Then I did the same thing here, tst fact here. Also linked to tst fact that we have here. So these tst facts we have here, and then btn facts we have here. So that's what is happening here. I'm just linking this to them. Okay. Then I have to have a click event, and to have a click event, I just have to have btn. So I'm just doing this same thing here. So btn fact. As soon as you bring the dot click, okay, as soon as you bring the dot click, it's realized you are trying to write a clickable event. Okay, so you just do that as well. Then I named that on fact button clicked. So this is something I named myself. Okay. Then I have to declare this. So tst fact dot test equals get random fact. So this get random fact you are seeing here. Okay. So this button when clicked on, what should it do? So it should change this. It should change the tst fact, which is here. It should change this. Okay, it should change this to the facts I've provided up there. I showed earlier on the facts I've provided here. So you should change that to that. Okay, so that's what you can see here. And I have this get random fact. You asked what is it doing there. So this is a method I just created. You can see it here. It's just a method to select random facts from the list. Okay, so I have the list here, but I want it to be selected randomly. Okay, that's why I brought in this method to do that. So I created this method to do that work. So what I do is this counts the method, and my selected random fact equals fact. Then so I pick any fact that is being produced here, which if I put in 0 here, I'm going to get the first test. I'm going to get the first fact. If I put in 2, if I put in 1, I'm going to get the second fact. But I'm trying to tell the system that anything that is being developed or anything that comes in the random should be input here. Then it should return the fact. Okay, so it should return my selected random fact. Okay, so that's what is happening here. So when the button is clicked, tst fact dot test equals get random fact. So everything here is what you see here. Okay, so get random fact. So let's quickly run this and see how it works since our time is far spent. Oh, okay, so our hello world is already running here. Um, yes, our hello world is already running, which we created earlier on. So, um, yep. Just a few seconds. Let's get this application running and see how awesome it's working. Okay, so I think, okay, so I think I have it installed, but so let me see which one is that. Okay. All right, so this is awesome. Let me see if I can zoom my screen a bit. Okay, so as you can see, um, that's what is happening. So when I click on new fact, it should change randomly. It should give me a new fact. So this is what is happening. Let me put it here for all of us to see. So if I click on the new fact, it's changed. If I click on it's changed, that's what is happening. If I click on it changed, then it gives me another fact. It changed. So this is a simple application built with .NET, C Sharp. I hope you guys really like it, and I'm going to put it in my GitHub in case you guys want to try your hands on. Why not? You can still try your hands on. So I've explained a bit of the code here as well. So the code I use, the main activity, then I have some resources for you in order to get started. You can get started with some few. You can actually watch this video. There's a video on Xamarin. There's a video on the Xamarin handle on that's YouTube. You can watch the video there as well. And you can create a simple application. Also, you can get documentation here as well. Then why C# for mobile development? You can read more here by Nat. So yeah, thank you for joining. I'm really grateful to be part of this conference. Yeah, thank you very much.
Thank you so much, Shadrach. That was awesome. It's always cool to see the newest stuff. I can't believe we have these simple like XML designers to visualize everything you're doing. It's so easy nowadays.
Sure.
I like
Sure,
it.
that's so awesome. There's more behind that. Yeah.
Yeah. So thank you for sharing the resources. One of the tweet questions were all about what can we do next? How can we learn more? So you shared those YouTube links and Nat Friedman's post on mobile development.
Sure.
Let's see if I can give you another question. So one question was, how good is Xamarin support for device hardware features like camera, GPS, or the accelerometer?
Yeah. So it with that, with this question, what I'm going to say, Xamarin is really good. It's really good in supporting these devices. And you know what we do in the other platform, which I won't mention the names, but what we normally do on the other platform by trying to do so much code and other stuff and all those stuff. Um, when you get to the Visual Studio, when you get to the Visual Studio, you don't need to even input in all those stuff. Okay, you don't need to be typing all these. I wanted to give a sample of that. When you come here, let me see if I can share my screen. Kendra, can you help me share my screen? I
I
wanted to
can
give
see
a
it.
scenario.
You're
Yes.
live.
So yes. So you don't need to even code. You don't need to code at all. It should be somewhere here if I can find that. Um, you don't need to code. It's just a button click to support whatever you want to do. I actually okay.
I know. Are you looking for
So
the
yes,
Actions tab to add events?
yes, so it supports native device APIs as well. Yes. Yeah,
Very
camera, everything. Yeah, yeah. So I'm actually trying to find a link whereby you don't need to even code. All you need is to just yeah. So you can put off my screen now. So all you need to do is just to click. If you want it to support your camera, you just click. You want it to support your camera. If you want it to support whatever you want, you just have a click, just a click away. Then it just yeah. So I wanted to go through that. There's so much already.
No,
Yes.
that's okay. I mean, I think we're ready for our next
But
session.
it supports everything. But it supports everything. Yeah.
Awesome. So thank you so much for joining. That's really interesting. It's always great to help people get started and share materials. And thank you for sharing your source code. I'm sure quite a few people really appreciate that as far as what I've seen from the tweets.
Sure. Thank you very much. And I will encourage the students to join Microsoft Student Partners, Microsoft Student Ambassador currently. Yes. So I will encourage the students who are also watching this to partake in that as well. So you can just visit the microsoftstudentambassadors.com and get registered. Yeah. It's an
Great.
awesome project for students.
Awesome. Thank you so much. So next up is Giovanni Bassi, and he's going to be talking about analyzing memory dumps of .NET applications. Hello.
Hey Kendra, hello from Brazil.
Hello. How are you doing?
I'm fine, how are you?
Doing great. Excited to learn more.
Great, that's what we're here for.
All right. Yeah, you want to take it away?
Sure, let's go. Hi everyone, I'm Giovanni Bassi. I'm a Microsoft MVP, and you can reach me at in Twitter at Giovanni Bassi. So if you have any questions after the session, I'm glad to help you because this is a quick 30-minute session. So let's dive in. So we're gonna talk about memory dumps, and then we'll see a little bit about WindDBG and symbols, and then we're gonna have some demos. So let's talk about memory dumps. So imagine you have a production problem, right? So your application is failing somehow and you are not sure why. So you might have a memory leak, you might have a high CPU demand, you might have crashes which you cannot reproduce. You cannot reproduce any of those. So what do? You cannot debug them, and when you run this application on your machine, it works, right? So you don't know what's going on and you can't debug. The environment is restricted or inaccessible, or maybe you do have access, but it's going to impact the performance and the application cannot be impacted that way. So in this case, you basically have a problem in production that you can solve through an easy, usual way, right? So what do? Memory dumps come to the rescue. You kind of take a picture of the memory, and you get to see everything that's going on within the application, and you can this picture is actually the memory dump, and you can then bring this dump to your machine, and then you can analyze it. You can take a snapshot this memory dump when you demand it. You can just run an application that will take the memory dump for you, or you can also trigger it when the app crashes or hangs. So you can leave it running for a while, and then when the application finally hangs, then you get the dump. It will bring all the application context for you, so environment variables and system information. So this is very dangerous because this includes all the application state, including secrets, connection strings, and all the system information that the application was using. So you should be very, very careful with how you handle this information. You shouldn't give this memory dump to somebody that doesn't have to have access. Usually what we will do is this memory dump will be analyzed in a lab environment with controlled access. Okay, so you should never ever share a memory dump freely. You shouldn't send it in an email. You shouldn't do that. Okay, always treating it as you are treating your connection strings very carefully. Dumps can be taken various ways. You can use the test manager on Windows. You can do it right now in your machine, and you can take the memory dump. You can use Process Explorer or Proc Dump from sysinternals. They will help you take dumps, and they actually you can configure it to, Proc Dump to take a dump at a specific point in time. Visual Studio is also able to take memory dumps. AD Plus is an old application from Windows that you can use to take memory dumps, and you can also set it up so you can take a memory dump on an exact point in time. And the two new ones are .NET Dump and .NET GC Dump, and we'll talk about those two a little bit more. I just want to show you how easy it is also to do it on Azure. It's super simple. If you access the Kudu environment on Azure App Service, you can simply right-click on the .NET process or the XC process you have running there, and just require the memory dump. I recommend you usually take a full dump, which will be the size of the memory, because it's actually a map of all the memory, so be careful with that because it might be really big. So if you're using, for example, 16 gigs of for the application, the memory dump will have 16 gigs. So this way, it's usually not the best way, because you'll be downloading 16 gigabytes to your machine and the connection may break and you're gonna have to start again. So this is not ideal. There are other applications, other ways to do that. We'll talk a little bit about symbols in a moment, but when you publish an application, you also publish the symbols. I'm just getting ahead a little bit so you know it's also there. And Azure App Service has a troubleshooting tab that you can use to also solve it. So if you click on diagnose and solve problems, you're going to have the diagnostic tools on the bottom right corner over there. And then you can collect a memory dump exactly on that point in time. And you can also monitor for crashes and transfer it to some storage account. Or you can proactively monitor the CPU and take the memory dump when some condition is reached. So it's super simple to use Azure App Service to take memory dumps. There's also an extension called Crash Diagnoser. There used to be a site called siteextensions.net. This has been replaced with nuget.org, and you can also use that to install that on Azure App Service. So you have several different ways to take these memory dumps. Now that you know what it is, let's talk about WindDBG. WindDBG is one of the main tools, I would say the main tool used to analyze memory dumps on Windows. This is an old application and very advanced, very complex, not intuitive at all, but very powerful. So it's a very powerful tool that you're gonna have to learn how to use if you wanna actually do this. Also, documentation on working with memory dumps is not that extensive, so you're gonna have to work your way to understand how to use WindDBG, and it's a really difficult tool to master, but it's also very powerful. They're starting to update it, and now they have what's called the WindDBG preview. It's on the Windows Store, so it's super easy to install and update. And it's much modern and easier to use than the old WindDBG that we had before. You might even have WindDBG on your machine right now, but I recommend you install the WindDBG preview because it's easier to use, and it has support for a much more things, much more functionality. We'll do a demo in the end of the session. You'll see how interesting this application is. You can also use .NET Dump. .NET Dump is a new tool here, and it's able to work only with .NET Core and .NET, now the new .NET 5, and also allows you to create and analyze dumps. Dumps can be created on one platform and analyzed in another using .NET Dump, what is not so simple to do using WindDBG. And dumps can be created with .NET Dump and analyze WindDBG. It's important that you understand that the commands in one tool are different from the commands in another tool. They try to make it similar, but sometimes they are a little bit different. Okay, so if you know WindBG, you might have to learn to do to work with .NET Dump and learn a few of newer aspects. But .NET Dump is a tool. It's a command line tool. It doesn't have all the windows and switches that WindBG has, but it's made to work with .NET, while WindBG was made to work with C++ and native applications, and .NET came later and was adapted later to work with WindBG. There's also .NET GC dump, which is a different thing. It actually generates a dump. It's a report that's you can use to open on PerfectView or Visual Studio. It's not a dump that you can open on .NET Dump or WindBG. It's different. It's easier to use than the usual dump analysis. So PerfectView and Visual Studio are easier tools. They are much more intuitive. And these are not compatible with other tools you might want to use. Usually, traditionally, we have been using to analyze memory dumps. It's only available for .NET Core 3.1 and later, so .NET 5 is also there. Let's talk a little bit about symbols. Symbols are super important. I showed you that when you publish an application, you usually publish symbols, and you have seen those. Maybe you didn't know what it was for, but those are those .pdb files that get published when you publish a .NET application. They actually connect your memory dumps to your code. So they are mapping what's in memory to your source code. You can have application symbols and infrastructure symbols, which is I'm calling here, which are usually the Windows symbols and for Windows APIs and .NET, the .NET libraries. They are what I'm calling infrastructure symbols. And you also have your application symbols. Microsoft publishes their symbols on a symbol store that you can, on a symbol server that you can download freely. I don't know if all, I cannot say that all applications have their symbols, but a lot of applications from Microsoft have their symbols published. So you can, all these libraries, you can download them from Microsoft's symbol server. And then, but they are really large. PDBs tend to be large, and also we have a lot of libraries, so they take a while to load. So a debug session, it can take a little while to be able to actually start. So usually what we do is we cache it on our local machines, and so the next session starts a little bit faster. The demos I'll be doing here with you, you're gonna see that they start really fast because the symbols are already cached. And also, it's important to understand that every time a library changes, a new symbol has to be published. So when Windows API changes or .NET API changes, they have to publish new symbols. So if you're debugging an application with minor, a difference even in minor versions, you might have to download new symbols, and it might take a while to download again. Also, this cache is usually large, so be careful because it takes a lot of space. WindBG already downloads the symbol by itself. You don't have to do anything. But when you're using .NET Dump, you usually use the .NET symbol tool to download the symbols before starting the analysis session. Microsoft publishes their symbol on this address, msdl.microsoft.com, where you can download from it. And for public symbols, you can use symbolsource.org and NuGet.org. And for private symbols, you can use Azure DevOps, MyGet, a shared network folder, and many other options. You might just publish them to app servers, for example, and then just download it from there if you want. That's totally possible. Private, it's very important that you store your symbols, or you won't be actually very effective when you're analyzing dumps. So if you forget to do it, you might have a little trouble. So use continuous integration in a symbol server for your symbols. That's the best thing you can do. By default, Visual Studio will publish symbols, and Azure DevOps will offer a way to store the symbols. So it's all there already for you. You just have to tweak a little bit, and it's going to be there. It's possible to download symbols from Azure App Service. I already said that. And let's go to the demos. I left a little bit of time for the demos because these demos take a little while, and I want to get a little bit deep into them with you. So the first one we're going to do is with WindBG. It's a memory leak with an ASP.NET Core application, and that's a 2.2 application if I remember correctly. Let's start. We'll start opening WindBG here. So it's already here. I already opened it, and I'll open it again so you can see. But basically, what you do is you have to know the address of the memory dump. I'll show it. It's this file here, which I'm gonna use. So it is 519 megabytes. That's the size of the memory that was being used. And remember, this is a memory leak. This application was leaking memory. So what you do is you come over here, and first of all, you have to stop the previous debugging, which I was just trying here. So you open a memory dump, and you just paste it, the link there, and it's gonna open for you. So it's just open. You can see a lot of information here about the dump already. So the system uptime, the process uptime, and other information. So we're going to start analyzing this dump. So the information that came to us is this application is leaking memory. As the time passes, it is using more and more memory, and we don't know why. So this is usually very common. In a large application, you can't find it because you run the application on your machine and you cannot find the correct place where the memory leak is. But users are usually using all the application and they find it, but we don't find it. So we take the memory dump and we analyze it. As this is a .NET, I don't remember, I think this is 2.2 or 2.1, you have to load SOS, which is a tool that will teach WindBG a way to talk to .NET. So I'm loading it on the bottom line here. If you look at newer versions of .NET, you don't need to do that. It already does it by itself. I usually would do a command called verify heap. This is usually very important to verify that the memory dump is sound, but sometimes it's not, and you have to take another one. If the memory dump happens to be taken when there's a garbage collection happening, memory might be in the process of being moved, and memory dump might not work. Okay, I'm not gonna do it because it takes a while. I already done this before and I know it works. We're gonna go ahead and skip it. But what I can tell you is sometimes verify heap fails and the memory dump is still usable. Okay, so you might try it before you even if it fails. So here we get the execution engine version. All the comments are a little bit weird like that. They're not very intuitive, as I said before. So this is using a server mode for GC heaps, and this is the SOS version we're using. We can take a look at the heap. So we can do to try to understand a little bit more about this memory, what was going on with it. So we use the command heap-gc, and we will show us all the memory. So we can see here that we have 4 heaps, as we had seen before here. So this is the first heap number 0, and we have the 3 generations here, where in the memory each of them start. And we can see their sizes as well. So we can see that on heap 0, we can see that it is 80 megabytes in size. And heap 1 is, that's not true, it's actually over here. And then we can see the second heap is at 76 megabytes, and then the third one is at 80 as well, and the last one is at 76 as well, and the total is 314 megabytes for the GC. This is the managed heap, okay? There's not analyzing memory dumps is kind of a process where you go. There's not a silver bullet in a way to analyze memory dumps. Okay, you go and you try to investigate. So it's very common that when you have a memory leak, you run this command, which is dump heap stat. This will show the statistics of the heap and what objects were there. So we can see we have a lot of memory. We have 96 megabytes going on arrays of bytes. okay? And we have 144,000 array of bytes in memory. That's a lot. So what we're gonna do is I will not click on this, because if I click on it, this is gonna run forever. So I'm just gonna copy the command and paste it here. But this will show me all the objects. But I want only the larger ones, only the ones that have at least 5K. So when we do that, it's still a lot, but we can look at it. So let's take this first one, for example, and see what's in here. So this is the object itself, the array of bytes, and we can see here in the context is already a string. It looks like something from a header or .NET, HTTP, something about HTTP. Let's get another one here, see if it's different. It's the same thing, very similar, actually very, very similar. On home context, that's a coincidence. Let's get another one. Okay, same thing again. Okay, there's a pattern here. This is interesting. Let's get this one that we just looked at, and let's find its GC root. Okay, so just arrow up and we do GC root, and it will show us the GC root for this object here. And the first thing I'll do is I'll search for my application here. What's in this? This is what's holding the array of bytes. Okay, so on the top here, you're gonna see that there's some system threading thing holding it. But in the bottom, it's the array of bytes, and I will try to search for something of mine here. And I can see it's right here. That's an SMTP thing. That's from my application, memory leak app, and it's holding a list of something. That's interesting. It seems that this is our object. So what we do now is we are going to take a look at this object. Let's see what's in memory for this object here. So we're going to call dump heap and try to show for this type what we have in memory. So it's going to show all the SMTP objects we have in memory, and also the statistics, how many we have. So we might have tens of thousands, we might have one, we might have 10, I don't know. So it just found here 2 objects, and we only have 2 objects. And one is a logger, that's not ours, and the other is an SMTP, that's our object, okay? So we only have one object, and it seems that this one object is holding a lot of array of bytes. So we can take a look at it. We can come here to this object, and this will show us the object itself, and this is the object here, the address of the objects, and this is the object, right? We are here. So we have an accessor, a logger, which is the logger we saw before, an accessor, and some contexts. Let's see what this context is. This is the method table. This describes the object. This is the value of the actual object in memory. Okay, so let's look at it, and we can see that it's what it is. It's a list holding an HTTP context, and it has here 4,000 HTTP contexts in memory. So we already know that our object is holding HTTP contexts in memory, and it's not supposed to do that. HTTP contexts are supposed to be disposed at the end of the requests. So we know this is the root of the problem. And at this point in time, I would go and ask the developers to look at the code and try to find out what's going on there. Why is this object holding HTTP contexts, and probably the error is there. So this is this ends this first demo. We'll go to our next demo, which is actually using .NET Dump, the new .NET Dump, which is also a little bit complex. So let me, we'll do this on Linux. This is WSL. So this is super cool because we'll do the whole thing in Linux, okay? And we'll create the application from start, okay? So I'll just run these commands here to create the application. So it's creating a new MVC application, and then we're gonna run the application. I'm gonna open another tab here so we can do that while it's publishing the application. And then we're going to run the application when it's done. And then in another window, we'll take the memory dump. Okay, so the application is running. And we'll run the process as it would be done on the server. So we run, let me increase this font size a little bit, .NET dump PS. It will show the .NET process we have here. So it's over here. This is the process we are going to use. I actually made it a little bit easier to actually do that. So we are going to collect this, oops, let me just copy the command here. Okay, this is going to get the PID of the process for us. So it's right here. Okay, and then we're just going to collect this dump. And we're going to see it right into this local. And on the logs, you're going to see that a dump was taken. Okay, so this is cool to see that it actually writes dumps as well. And we can check it out now. Let's see how it is, how large it is. It's, oops, 300 megabytes in memory. That's the memory that was in use. And we're going to analyze this memory dump. There's nothing much to see here. But it's interesting for you guys to understand that we can do it. Okay, so for example, we can come here and see the version as the same thing we did before. See this, the command is actually the same. So you can see that this is .NET 5 as expected. We can see the heap. The same thing, the same heap we saw before, but now this is in Linux. And we can also see the stack, what's on the stack. And I'm going to add a -a here, so you can see details from the stack. So you can see exactly what's running right now, how many threads we have. I think we can run threads here and see the threads as well. See, these are all the managed threads. We're on thread 0 right now. This is where the asterisk is there. And this is showing us, it actually links to the source code because it found the symbols. So it's linking to the source code to exactly what's running right now. Okay, and then I would start investigating the same thing I did on the other application. I would do here. There's a help command if you need, so you can try to understand what it's doing. Okay, so this is how you start using with .NET Dump. You don't even need to install WindBg. Okay, and this with that I end our demo. And I'm going to leave the reference here a little while, but we can take some questions if you want now. But these are the resources you need to start working with analyzing memory dumps. Okay, there's a lot of docs here on Microsoft Docs. Documentation on WindBg is a little bit harder to read and more difficult, but it's also there. So here are the other tools as well. So that was it. And if there are some questions, we can talk about them. Kendra.
Thank you so much, Giovanni. That was so cool. Yeah, there's so much that I still have to learn about analyzing memory dump collection. I always end up on documentation so quickly.
Yes.
We got some cool questions on Twitter, but we're going to go ahead and skip on to the next. If you are available to answer any of those, I'm sure they really appreciate it. But thank you so much.
All right. I can take questions on my Twitter if anybody has any questions. And thank you, Kendra. Thank you, everybody.
Great. Lots of awesome excitement on Twitter. But next up, we got to keep moving forward. We have lots of cool things to show. Next, we have Nico Pays talking about enhancing test readability with extension methods and fluent interfaces. Hello, Nico.
Hi, Kendra. How are you doing?
I'm good. How are you?
Fine, thanks.
Excellent. If you want to take it away, I'm excited to finally get a testing talk. That's my jam. Let's do it.
Okay, here I go. Hello, everyone. I'm Nico Paez. I'm a software engineer. I share my time between industry and academia. I am a professor. I teach software engineering, and I'm a TDD fan, right? So that is why I'm talking about tests, right? So let's start. So the motivation, why test code matters. There are several reasons for that. Let's review some of them. First of all, if you work in a CD, CDI context today, which is something very, very common, tests are first-class citizen because the test represents your safety network. You plan to be updating your application very frequently, and you don't have time to run manual tests, so you need automated tests to give you some security on each update, on each deployment, right? At the same time, if you work in an agile or extreme programming way, well, tests are documentation, right? You, beyond using TDD or not, you will have tests in this context. And of course, working in an agile way is something very common nowadays. And in that context, tests are documentation. And of course, when you read your documentation, you want it to be clear, right? And something that is very common, you create some code, you write some tests, and when you have to update your code, of course, you will have to update your tests. So this again makes test a first-class citizen, right? Of course, that if you are practicing TDD, your tests are a design tool. So again, this gives test more and more relevance, right? And something that is interesting when you start thinking about test is that your test code is specific, while your application code is generic. You have to prepare your application to handle several situations that you can not, how can I say, sorry, your application code is generic. You have to manage several situations, but your test code is specific. In each test, you are addressing one specific test case, right? That implies that when you are testing your application, it's possible to have much more test code than application code, right? That's not infrequent when you practice test-driven development, right? And something interesting is that when you start paying attention to your test code and you find yourself reading test code that is not clear, sometimes that situation signals some design smells in your application code. If you have to write a test and your test is really long and you have to perform several setups before running your test, that may be a design smell in your application, right? So finally, we find that usually test cases share structure, right? Because you have to test a certain feature, and for that certain feature, you need to test several cases. Many, many times, the difference between the different cases you want to test is just a small difference in the step, a small difference in the test data that you will use, a small difference in the assertions that you will run. So that makes test code very easy to be duplicated, right? Something that, of course, that we want to avoid, right? So in order to tackle these situations, in order to follow this motivation, I want to share some techniques that will help us to have more readable tests, right? So the first of them is the object mother pattern, right? Here you have a link. So basically, a very easy definition for this pattern is a class that provides methods that create valid and customizable domain objects. In other words, an object matter is just a factory object, right? But with some specific conditions. It won't create application objects. Sorry, it will create application objects, but to be used in your tests. I mean, your application won't use the object matter. Your test code will use the object matter to get application objects, right? Your application object, your domain objects may be quite complex to build. And of course, at the same time, you may need different combinations of your objects with different data, with different status. And the object model will simplify that setup, right? Another technique is the builder pattern. You may already be familiar with this. We will use the builder pattern when creating our objects requires, let's say, a more complicated setup. And finally, we will use fluent interfaces. This idea of fluent interfaces, here you have a easy to read link by Martin Fowler. A fluent interface is just a way to organize our code in order to make it fluent when you read it, and of course when you write it, right? I will show how to use this, right? These three techniques are able to be applied no matter what language you use, right? But when we come to C#, we have some additional techniques to apply. In fact, we have specific tools in the case of C#, right? So the first tool I want to mention is the fluent assertions. This is a very simple library that, following the fluent interface idea, provides fluent assertions. The best way to explain this is just an example, right? So here we can see different assertion styles. The first situation is the traditional NUnit assertion, right? Assert at equal, and you give it to different things you want to compare. That has been present in the test framework for a long time. You can find similar methods in every XUnit tool, right? JUnit, NUnit, XUnit, wherever you want, you will have something like this, assert at equal. In the recent years, NUnit included a new type of assertion that is more specific. This slide is not updated. I will show this in code. It doesn't matter. In the recent years, NUnit added another assertion that is called assert that, and that allows a bit better, more readable way of assertions. And the last one that I want to focus here is the fluent assertion. This is part of the fluent assertion library, and look how it looks. Function transfer state should be, these are like extension methods provided by the fluent assertion framework, and this allows you to read in an easy way, we could say, right? With more, well, in a fluent way, right? The other thing that is interesting to add, the other tool that we have when working with C# are extension methods, right? Extension methods, for those of you that are not aware of this, are methods that are defined outside of a class but can be applied to objects of a certain class, right? So the way that we use this in the context of tests is that you will have your domain objects, and we will write extension methods in order to simplify the manipulation of our domain objects. That's it. So I think that this is enough, and let's go to code. Here I have my code. You can access at GitHub. I already shared my solution there, so you can check it there. And let's browse the situation. Okay, for this demo, I have a very simple domain, a bank domain, where we have a funds transfer object that will perform funds transfer between bank accounts. The bank account belongs to a customer, and the bank account is located in a certain branch, and the branch is related to an address, of course, right? So this is my simple domain model, and let's see how it works. So in code, this is my sample project, just the domain project, the class library, and then another class library for the test. In this case, I'm using traditional end unit, right? So we can see we have our bank account and our customer and our funds transfer, right? That it's been created, some validations are run when it is created, and then we have an execute method that just take the money from one account and put it into another, and of course change the state of the funds transferred, right? So let's see how we test this. I developed this small domain using TDD. So we have here the corresponding tests. As you can see, I have tests for the main classes. For the branch and the address, I didn't add tests because they have just a bunch of data with no behavior at all, right? So I have tests for the fund transfer, for the customer, for the bank account. But beyond those tests, I have prepared 2 additional classes with tests after and before applying the techniques I have mentioned here. So let's start by analyzing the tests without applying the techniques I mentioned here. So here we have this test before refactor. And in this case, we have a first test method that tests the funds transfer state is pending when created. So this is what we want to test, right? As you can see, this is a classical test with 3 stages. In the first place, we have the arrange when we prepare the context for our test. Then we have the act where we perform the action that we are trying to test. And finally, we have the assert where we verify that things are expected. Look at this. This is the key part of our test, but in order to be able to execute this, we have to perform some setup actions. And this is just testing my domain. We are not testing infrastructure that sometimes that requires some more preparation. The point here is that I want to test the funds transfer, and for that, I need 2 accounts, the source account and the target account. But in this case, the bank account has 2 collaborators. We have an owner, the owner of the account, and the branch where the bank account belongs to. So in order to create my bank account, I need these 2 objects. Of course, that in some situations, I could just put null here, but that could bring some, let's say, collateral effects, right? Some unexpected situations. So I will pass it some objects. Of course, that another option could be just mock these objects. Yeah, of course, that's an option if you are a mockist, right? You know, inside the TDD community, there are different TDD styles. One that is based on mocks, and another one that reject mocks, right? So in this case, I decide not to use mocks, so I have to create my objects, right? So to create my account, I have to create a branch, and for the branch, I need an address, and I need also a customer that is the owner of the account, and for the customer, I need a fiscal identifier, right? That the fiscal identifier is just a GID, right? I just have this data generator that generates a GID. That's all, right? So this is my test, right? This is like a unit test. I'm just focusing on the creation of the funds transfer, right? I can run this. And beyond this, I have a second test. Yeah, okay, it worked okay, excellent. And I have a second test that is a little bit interesting. funds transfer, debit in source account, and credit in target account, right? So in this case, the setup is similar, but it's different what we are executing. Our act is this one. We are testing the execution of the funds transfer, right? So here I create the funds transfer, and here I perform the extract of the money, and I move the money here, right? But again, in order to be able to execute the funds transfer, I need to create the funds transfer, and to create a funds transfer, I need several things, right? The same things that I needed before, but in this case, I need some additional setup. I need to put money into the source account, right? And also I need to know how much money I have the target account. And as you can see, I have here like 3 asserts, right? This is not a unit test. We could say that this is like an integration test or a component test or a social test, because I'm not testing this isolated transaction. I mean, I'm not testing the funds transfer in an isolated way. I'm testing the funds transfer object when he interacts with the sources, with the source account and the target account, right? That's why I call this a social test. So this is my code, and I think that applying the techniques I previously mentioned, I can make it much more readable. So let's see how this looks after the refactor. This is the situation we have. This is the first test. As you can see, these first lines, I don't matter any of this for this test. I'm just testing the state of the funds transfer when I create it. I don't want to know all this stuff, right? So what I did here, I have my object matter, and I just say, just give me a bank account, right? As you can see, this is like a factory method, right? Just give me a bank account with some preset configuration, and this method will take care of all the complex things, right? It will create the address, the branch, the customer with some default values, and just instantiate the bank account and give it to me, right? So this code is much more simpler than the previous version, right? And in the case on the other test, in this case, I need a source account, but with a certain state. So I ask my object mother to create a bank account, and I need that bank account with certain balance, right? So in this case, of course, one option could be just put here the parameter, right? How much money I want in that account. But I decided to implement this with an extension method to set the balance, right? So we have the create bank account, and then we have the extension method, right? That, of course, operates on a certain bank account, right? And I set here the amount of money I want on that bank account, right? And I also abstract the detail that in order to put money on that bank account, I have to call the credit method, right? So even more, this extension method could be used on any bank account, right? Inside my tests, right? The extension method is only available in my test code, right? So this allowed me to have this simple code, right? And in this case, I'm using here the second end unit assertion style that I mentioned previously, right? Assert that source account balance is equal to. I could refactor this into the fluent assertion style and just say source account balance should be 400, right? This is exactly the same as this, right? But this is in a fluent assertion way, right? So I will replace it. Thanks. And going a little bit further with this, let's suppose we have another test here where the branch is relevant, right? In these two tests, the branch was not relevant, right? But for certain situations, I may need some specific state of the branch, right? So how could I manage that? Well, first of all, we could say, well, let's use the object matter and let's add to the object matter after the bank account, we create some additional extension method to set the branch number, right? We could do something like this, right? Or at least we could try, right? So we can create this at branch number and make this method, NET extension method, to create a branch and set the branch of the account. But we will have a problem in that situation, right? Look at this. I have my object matter here. Here is my balance method. So I will create another extension method that we will call at branch. Of course, when you create a Fluent interface, that is what I'm trying to do. I have to return the object where I'm trying to operate, right? So my extension method receives a bank account and, sorry, my Fluent method receives a bank account and returns a bank account, right? So I have to return a bank account and I receive this an extension method. So this is my syntax, bank account. And this should receive, for example, the branch number, right? So here I could try to do something like this, right? But the problem here is that if the bank account is already created, I cannot change the branch, right? As you can see, this does not allow to change the branch, right? This is just a read-only property. Well, not a read-only, but a private set, right? Just to be used when you create the bank account, right? This is like a domain-driven design restriction. From a conceptual point of view, in this domain, when you create the bank account belongs to a certain branch, and you cannot modify that branch, right? So in this case, I cannot apply this technique, right? The object matter will be very useful when you have to operate on properties or on methods that you can operate, right? In this case, I cannot use the object matter to operate on the branch because the branch is not settable, let's say, right? So what can I do in this case? I can use another pattern that is the classic builder pattern, right? So let's forget about this and let's look at this. In this case, I have an object builder. I say the object builder, I want a bank account for the customer John at the branch 1 with balance 500 build, right? And here I have that account with that state, right? How does it work? Well, the object builder just takes these parameters, and when I say build, at that point, the object builder calls the constructor of the bank account in this case. Look at this. I say bank account, it just creates the object builder and returns it. Then I say for customer John, so the object builder just take that name and store it and returns the object builder so I can continue my chain of methods. So I say at branch 1, and it stores the number of the branch. Finally, I say the balance, and it stores the balance. And at the end, when I have set all the properties I want to use, I just call build. And at that point is where the object builder will take all the information that is stored, and finally it will create the bank account, right? Look at this. I may use these methods without some of them, right? So in order for this to work, I have some logic here to set some properties with default values, right? If the customer name is set, then the builder will use that name. If not, it would call it Mary, right? If the address, well, I have the address is not relevant for this, so I have a default address object. But the same happens with the branch number. If the branch number is set, okay, use it. If not, use branch number 1, right? And something similar with the balance, but it's a bit more complicated. If the balance is not set, okay, just return the account as it is created. But if some balance is set, then put that money on the account, just perform a credit operation. Well, I think this is all. That's it. I don't know if you have some questions.
Yes, we do. So thank you so much. That was very interesting, very great, clean test code with writing extension methods without having to change your actual production code, and all of your tests actually look readable and legible. It's so good. So one question was, what is your personal approach to doing spec flow or business logic testing versus unit testing, method or functional? So how do you kind of split between the two, and is the simplest form of spec flow just becoming a unit test anyway?
Okay, I do both of them. I follow what is called the London approach, or the London TDD style. You can check about this in a book that's called Growing Object-Oriented Software Guided by Tests, right? Growing, here it is. Show me an image, please. So this book is great, and as you can see, this is the key to your question, right? You will write a failing acceptance test using a spec flow. That is a test from the user perspective, right? That will check a business transaction. But in order to make that test pass, you will have to do some small tests on your objects, right? So at this point, you use a spec flow, and at this point, you use a unit or another more developer-centered testing tool.
Great. Well, thank you so much. We had a few more questions on Twitter if you want to hang out there and keep a look on your notifications. But thank you so much for joining.
Thank you so much. I will check the questions on Twitter.
All right. So I want to introduce our next host. I'm actually going to be handing it off to our very own John Galloway.
Woo!
Woo!
Awesome, Kendra. Awesome. In case that hasn't been said enough, love the hair. It's amazing.
Thank you.
Yeah, I am excited to be taking over for you. Thank you for all the exciting hosting this morning. And I'm also very happy to start this off with Carl Franklin. So Carl Franklin's going to be talking about application state. It's you.
What? Really? I didn't have this on my calendar.
Well,
wow.
I'm sure you can just present right off the top of your head. And I'm excited to hear about application state. I've run into problems with this where you start building up state in a component, and then you're stuck when you have more than one component and all that. So I'm excited to see what you've got to show.
Great.
All right, let's get going.
I'm ready. So welcome, everybody. My name's Carl Franklin. I don't need to reiterate my bio here, but you can just Google me. I've been around for a long time. I'm an old guy. I've also been involved with Blazor since the early betas, and I do a weekly YouTube show called Blazor Train, and you can go there at blazortrain.com. And in Blazor Train, I actually did this content, but I build the applications piece at a time so you can understand them a little better. So I'm just going to show the done applications in this talk, but if you want to see them built, one at a time, piece by piece, you can go to blazortrain.com and check them out. All right, let's get going. So what is application state? So application state is essentially where you have instances of objects that are stored in memory. And normally these would be, in behind a page in Blazor, behind a component, but sometimes you want to share those things. And so because Blazor is a SPA framework, SPA applications are inherently stateful. So it's kind of important sometimes that your application knows what all those variables are, not only to be able to access them across components and pages, but just in case things happen, you might want to persist those variables in that application state and then reload it later. So what we're going to be doing is creating a state bag. I'm sorry, did I offend somebody with that? A state bag. State bag is just a class for accessing all the object references that you want in your application. And the idea is that you get one instance per user. So one user is not sharing that state bag with another user. Fortunately, in .NET Core, we have these user scope services that we can create. And if we create a state bag class and we put all our public properties and all that stuff in there, then we can add that as a user scoped service or a scoped service, which means we can share that between pages and components. We can inject it into whatever page we want. It's one source of truth, and it also allows for stickiness. So while we're talking about scope, excuse me, while I have my breakfast. While we're talking about scopes, let's talk about the different scopes that we can have in ASP.NET Core. We have per user instances, and this is what we're going to use for application state bag. So think session in web forms. And the only reason I'm bringing this up isn't because of the technology behind session, but the accessibility. And it was very popular in web forms to have this session object that we put stuff into and take stuff out of while the user is online. So we don't have a session object, thank God, in ASP.NET Core, but we do have the ability to scope any object to the user. So this is a per user instance. Now, a per application instance, we have these as well. And you can think the application object in web forms. This is a good place to put static data, data managers, helper methods, anything that doesn't require per user access. Okay, we have those as singletons. Now, singletons, we'll talk about that because in a Blazor WASM app, there really isn't any need to do a singleton versus a scope because there's only one user. But then we have just your basic class instances. Okay, so class instance is essentially transient, and that is essentially what's going on there. So if I create something at the top of my page or whatever that just lives with the page, the counter is a perfect example of this, right? You move off the counter page, you move back to it, and that counter has completely reinitialized. So you can add these instances with scope in Startup CS for Blazor Server and in Blazor WASM in Program CS. So in Services CS for Blazor Server, we have in Configure Services, you can add transient, right? So this is for that class level. And you would do this instead of just creating a class level variable if you require dependency injection. So if these classes have to be set up with dependencies before you use them, this is a great way to do it. Add scoped is that per user scope. Every user gets their own instance. And add singleton is the application scope. So in Blazor Server, one instance is shared among all the users. And in Blazor WASM, it's the same as a scoped service because there's only one user. You're not going to have more than one user. It's running in the browser, right? So let's just dig into these for a minute. This is sort of repeating what I just said, but transient scope is the default for component variables. It's reinitialized on navigation. It cannot be accessed by other components. And if you want to add dependencies, you use add transient. The user scope is services add scoped of whatever it is. It can also have an interface in front of it. So if you want to add it as an interface and then the implementation, that's good. You get one instance per user, and this exists outside pages and components and can be accessed by other components just by injecting them into the pages and components. So this is perfect for application state, and this is what we're going to use. Application scope, add singleton. It's Blazor server only. Obviously, you can add singleton to a WASM project, but it's going to behave the same way because there's only one user. Okay, and this one instance is shared among all users. So if you look at the default template, the weather forecast service is implemented as a singleton because it's just creating some dummy data and it's not, there's no state there, right? So this is a good place for static data and methods. So the downside of transient data, which is the default, is that multiple copies of the same data are used across across pages. So that means that every page has their own instance of this data and one page cannot see another. And so think of a situation, well, I'll get to the situation, but synchronization headaches. This is what this will cause. And it's not one source of truth. So here's the scenario. You have a toolbar component, right, across the top of your page that stores lists of objects that are used in the current page, whatever that page is. Right, so the user maybe selects an object in the toolbar with a drop-down perhaps, and then selects a button to load an edit page below the toolbar, which then the user edits. So editing the page retrieves the selected object and allows for editing. So if the page isn't using the same object that the toolbar is using, you've got two copies of that selected object existing, and now you have to synchronize those things. And it's a pain, and we shouldn't be doing it. So the solution is to move those objects into a state bag, a scoped service, where they can be accessed both by the toolbar and the edit page. Oh, my coffee is here. Hello.
Who are we talking with?
I'm talking with the world right now.
Can I say hello to the world?
Sure. Kelly, ladies and gentlemen.
After I pour the coffee, of course.
Quickly, because I only have a half an hour, but
Hi.
here's my the one who must be obeyed. Thank you. All right. So the solution again is to move those objects into a scoped service, a state bag or app state, where they can be accessed both by the toolbar and the edit page. So there are three ways to implement a state bag. One is the easiest way is with a cascading component. So the app state itself is a component. It's not a service. It's not something that you inject. It does not allow for notifications even though the UI updates. Now, what I mean by that is when you change a property on an object in a cascading component in any page, any other page that is bound to that property is going to immediately update. However, if something like the toolbar or a page or some other component needs to know, needs to get control, needs an event handler when that happens, you can't do it with a cascading component, as far as I know. So the next way to do this is with a scoped service. So with a scoped service, you can inject it into any component that requires it, as I said, as a add scoped service. And it's useful if you need to raise these notification events, but it does require some event handling code, and therefore implementing iDisposable in any component or page that needs to handle that event. Now, there's a hybrid approach, and I think this is really good because it is a cascading component around everything, but then the app state is a property of that component, and we can still get control if we want to do the event handling wherever we need it, but we don't have to. And same with the scope service. You don't have to handle the events if you don't want to. The events aren't for updating. It's going to update because it's bound. Properties will update automatically. This is only if you need notification. All right, so for the cascading component method, we're going to create a Razor component. I called mine cascading app state. Of course, you can call it whatever you want. You add public properties to be shared across components. And then you enclose the entire router in AppRazor with this cascading app state. And then anywhere you want to use it, you declare it as a cascading parameter. All right, so let's look and see what that looks like here. Let me pull up my demo. Everybody see this okay? I hope you can. So this is just a Blazor server application. It'll work just as well in a Blazor client application. And this is called app state via component. And all of this will be available to you later. So what I've done in my shared folder is I've added a cascading app state.razor component. And let's see if I can, no, it's all right. All right, so you see this cascading value up here and wrapping a child content render fragment. So this is an easy way to say, hey, we're going to enclose this component around other things. This is the other things right there. That's a render fragment. So that's anything in the app at all. In fact, it's going to be the entire app. Now we have 3 properties. And the reason that I have these broken out like this is because I want to call state has changed when we set any of these values. So I've got counter, I've got message, and I've got enabled. That's it. So in the app Razor, now I have completely wrapped the entire router in this cascading app state. So let's look at the toolbar. And yes, I have created a toolbar component. And this just has a div with some styles in here. And if app state, here's our cascading parameter, cascading app state right there. And just by doing this, we get access to it. So if app state enabled, we're going to show a button with, the success class enabled, disabled. So that's cool. And then we have this other button, update message button clicked to update a message. And we're going to set the app state message to message updated at date time now, too long time string, just so that we know that's happening. Now, my main layout Razor, I've replaced this default about thing here with the toolbar. So the toolbar is going to go at the top of the page. Now in the index page, get this, I also have access to that cascading parameter, the app state. And I've got 2 buttons, one to toggle enable button clicked and the toggle the update message button clicked. So this is just exactly, no, never mind that. So 2 buttons, one to toggle the enabled property, one to update the message. And that's all we're doing is we're just changing those properties on app state. Okay. So let's run this puppy and you'll see what I'm talking about here. Oh, remind me to tell you about child component. I'll show that afterwards. All right, so here's my toolbar, right? This is not an enabled button. This is just a button that's showing enabled, disabled. From the toolbar, I can update the message. Now this message is on the app state, so I'm showing it here and I'm showing it here, right? Anytime I update that, it updates. Now I can toggle enabled from the page, and because it's also bound in the toolbar, that shows there. Toggle enabled. I can also update the message from the page. And I have a child component that can update the message as well. And let me show you that child component. It's very simple. I just have the cascading parameter app state in there, and I'm just setting app state message equals updated by child component. That's all I have to do. All right, let's talk about using a service. So to use a service, we're going to, and what I did, you can knock yourself out naming wise, but I created a class called AppStateCS in the services folder. And I added a public event for change notification and a private method to raise that event. And now AppState properties should be defined with private setters. And then each property has an update method that sets the value and raises the notification event. And that prevents callers from circumventing the event system. So in Blazor server, I'm going to add it to services.cs as services.addScope to AppState. And in Blazor WebAssembly, I can do this in program.cs, builder.services.addScoped. So in the components that use the app state, I inject the app state service, I implement iDisposable, I handle app state state change, and there's two parameters, a source and a property name. So the source gets set by whoever raises the event. This is my component. And the reason I do this is so that I can check to see if it's not me before I act on it, because I'm handling it and yet I may be raising the event. But I want everybody else to get the event, not me. So I test that source to see if it's this, it's not this, and I inspect the property name, take appropriate action. Now remember, notifications aren't UI updates. UI will update automatically. Notifications are for, hey, I need to know when somebody else updates this property. So we're going to hook the event in onInitialized and unhook it in disposed. So let's see that demo. So here's my app state in services. I want to keep an eye on the time. App state and services, I have my message enabled encounter with private sets. And then I have an update method for each one. And then I'm going to call my notify state changed. Okay, here's my state changed event. Here's my notify passing the source and the property. So here's my startup. I'm going to add that as a scoped service. In toolbar, I'm injecting the app state and I'm implementing iDisposable. All this UI is the same. But instead of a cascading parameter here, I've injected app state. So on my update message button clicked, I'm going to call app state update message this, because that's who the component base that updated the message. And in state changed, I'm going to, if source is not this, that means somebody else raised the event. I can inspect the property, whatever it is, see if action needs to be taken. And here's where I hook and unhook the event. Now this is going to look exactly like the last one, except that we have this added layer of functionality where we can figure out who raised the event. All right. So it's going to look exactly the same. Here's my component. All right, let's get back to here. All right, so the hybrid state bag uses the app state service as a property of the cascading component, and it allows for persisting the state bag. Now, why persist? You want to restore the state of the application between browser visits. So one scenario, filling out a long form, how many times have you had to fill out a form? And then it asks you, like when you're almost done, you know, what was your median income in this year? And you have to go look it up, you come back and it's timed out. If you have a network outage, you accidentally close the browser, that kind of stuff. So on the client, we can use secure local storage, but and this is new in .NET 5, and I'll show you that. You can use local storage too. I would recommend, if you can use secure local storage, that's great, but just think about not storing secrets. That's not a good idea in general. So you want to store just like the basic stuff that you're looking at, as long as it's not sensitive data. You get 5 megabytes of a limit of data per URL with local storage. And this is what we're going to use. On the server, on a server, of course, it's not you don't want to use a shared data store, but you certainly can persist it to a database. The downside is it requires a network connection. So here's the app state persistence pattern. We're going to choose a component that's always available, like the toolbar or the nav bar. We're going to access the cascading app state provider. We're going to hook and unhook the same way we did with the service. And on the state changed, we're going to persist the app state. Now, you only want to do this in one place. That's why you got to choose one component. We're going to use a JavaScript wrapper to local storage. And then I'm going to show you how to use the new protected browser storage in a Blazor server app. And yes, it only works in a Blazor server app. So here's my hybrid. And just about everything is the same here. This is the cascading app state parameter. Here's my child content, my app state as a property. I've got a key for local storage. And also check this out. I've got two functions, get local storage value, which just says local storage key equals value, and set and get. So this just wraps the JavaScript local storage. Okay. So back here, what I'm doing is I'm on parameters set async, which means I'm reloading the page. I'm getting the local storage value, and I'm deserializing that with the JSON serializer, and I'm setting app state. Now I have a save changes, which is not async, and I have a async save changes. And so if I'm saving changes, I serialize the app state to JSON and set local storage. Now this is the clear text version. So let me show you what that looks like and why it's a bad idea in local storage. Bad idea. All right. So here I've got my tools up, my application, local storage right here. I'm going to update the message. And now you'll see in clear text, look at that message updated at blah, blah, blah. All right. Anyone can, not only can they see that, but they can change it. Like anybody with the browser tools can change this value. Message not updated. And then when I reload, they've actually changed my application state. So that's not good. Okay. But let me just get rid of all of this stuff and show you that everything does work the same way as it worked before. All right, let's switch over to using the new and shiny protected browser storage. And you can see I've injected this this is a .NET 5 application, obviously. So let me get this out of here. I'm changing my key to app state JSON protected. I will comment this out. And where did my comment toolbar go? That's great. View. Toolbars. Edit. Where's edit? Text editor. All right, here we go. We will now use the new .NET 5 protected local storage. It only works on the server, and a moment's thought will make it clear why. The server is going to come up with the encryption algorithm that stores that for you. And so therefore you do not want that on the client. You don't want the client mucking around with it. On this side, when we save changes, we're going to use protected local storage as well. And this is all there is to it. Like it's local storage get async. We're getting a string, we're getting the key, we're deserializing that. And over here, when we save it, we're setting that JSON with that key with protected local storage. Let's run this and see what happens. Again, we'll pull up the tools. We'll look at local storage. Here's our clear version that was there before. Now, when we update the message, doop, gobbledygook. Now, here's what happens. If I try to change any of this and I reload it, yep, it just creates a new app state. So basically, it's not messable. Is that a word? Messable. All right, there you go. So kudos to the .NET team, the ASP.NET Core team, for getting that protected browser storage working. So in summary, managing application state is really necessary in a SPA because SPAs are stateful. You want to move required references into a state bag, implement app state as a cascading parameter, a scoped service, or a hybrid of both. And to persist, use the hybrid model because you get the best of both worlds. Now, I just want to call out Blazor train, and this is me shouting at a passenger on my train because they're heckling me from the sidelines. If you go to blazortrain.com, there's a whole bunch of free content there, and I do a new show every day. And I also want to mention that DevExpress sponsors Blazor Train. It wouldn't happen without them, so thank them next time you see them. And thanks for joining. That's it for me. Back to you guys.
Wow, Carl, this was great. I think I have time for a few questions here.
Okay.
So one thing here that came up was this, is there a way to programmatically check to see how much local storage has been used?
Yes. As a matter of fact, I did show that. I don't know if you saw that, but here, app state size 75.
Ah, there it is. Okay.
It's just essentially when you serialize that string, you just get the length of the string, and that's what's saved.
Okay.
That's
awesome.
simple.
Very cool. Another question here, and kind of related, but is how are secrets stored? And you were showing app state, but I think you kind of want to. One thing is the whole kind of encryption thing, but you also want to kind of not be sending state down to your clients as much as possible, right?
Well, yeah. So when you save state in local storage, what happens is it goes boing, 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 right? So your app updates it, it goes to the server and then goes back to the browser, which persisted in local storage. And then when you want to read it, it has to go back through, I mean, if we're talking Blazor server anyway, it has to go back through SignalR and then back down to your client, right? So I think, 5 megabytes is the limit for a reason, that you shouldn't be storing a whole bunch of stuff in there. And it's my thought that you probably shouldn't be storing, well, you definitely shouldn't be storing anything that you don't mind the user messing with. And you saw how easy it was for me to mess with that local storage, right? So if you want to, you can persist it on a data store, just with a regular API call or something like that. And the downside again of that is that, you have to have an internet connection. And sometimes state is useful, like filling out a form or whatever. State is useful when there is no internet connection, or the internet connection goes down.
Very cool. Well, that's all the time we have. This was an amazing overview and really good information. So thanks a bunch, Carl.
All right. Woo woo.
Awesome. Okay, that was great. I am excited about this next presentation. Lizzie is going to be talking about migrating applications to .NET Core. Lizzie, so you're a developer at MasterCard, and you've worked on this sort of stuff at scale, right?
Yeah, definitely. So this has kind of been my main project that me and my team have worked on for the last 2 years.
Wow. So this is real world stuff. So I'm really excited to see it. Take it away.
Yeah, awesome. Thanks so much. All right. So hello, .NET Conf. So as shared, my name is Lizzie Gallagher, and I work at MasterCard. For the last 2 years, I've had the joy of co-leading our effort to migrate a large number of our applications to .NET Core. So today, I'm really just going to tell you a story. It's a story of some of the highs and lows of this migration effort. It's going to be a story of some of the decisions that we made, both the good ones and the bad ones. Now, I'm going to tell the story at a fairly high level, kind of give you an overview of the playbook that my team followed for this migration. So if you're watching this and you're exploring doing a similar migration for your company, I don't expect this talk to provide you like a precise map to your destination. But I do hope that hearing our story and the questions that we asked and the ways we answered them will help you anticipate those questions and the challenges that lie ahead. Before I begin, one caveat. This talk completely skips over evaluating whether .NET Core is, quote, worth the effort of migration for your company. I won't lie, this migration did take a lot of effort, especially at the scale that we are working at. And even in the best of possible cases, .NET Core, the migration, getting there can be fairly disruptive. So it's a caveat, we're not going to be answering that question. But with that aside, are you guys ready for some .NET Core? All right, let's go. So 2 years ago, my team, there are 5 of us, 5 developers, we wrote down our goal, which was to migrate all applications in our platform to .NET Core. Now, let me provide you some context by what I mean by our platform. This is an artistic rendering of our platform. It is a web of .NET microservices with 160 web applications, 90 console applications, and 300 internal NuGet packages. I don't know who you are. I don't know whether these numbers strike you as small or unbelievably large. But I do know that I personally felt a sense of dread when we first pulled these numbers and starting out on the migration. This many applications seemed entirely out of scope for my 5-person team to migrate all ourselves. So we immediately started by trimming our aspirations because we didn't want to have to abort the mission immediately. So if our original goal was to migrate all applications, our revised goal was, what if we just migrated those that are actively developed? Because one thing that my company has, and your company has, and all companies have in common, is that we have legacy code. Applications that have chugged along happily for many years with little intervention. So little intervention that no one maybe quite remembers the last time anyone made a meaningful change to the code. And so by having our team narrow our focus to just actively developed applications, we ensured that there would always be what I'm going to call application experts. Now, you may have another name for this kind of person, maybe a product team or members of a development domain. What I mean when I say application experts is a group of technical folks who know an application well enough to confidently make changes. Application experts are those who feel ownership over an application and responsibility for its health and stability. Let's jump back to our platform. As I said, ours is a microservices architecture. So one product is made up of multiple applications, maybe a few large applications, maybe a few small applications. And maybe these products also share foundational services like the application for authenticating users. And within each of these little squares, you have application experts who feel ownership over that set of applications. Okay, so we have narrowed our problem space to just actively developed applications. So our next question to answer was who should do the migration? i.e., who should make the code changes? Who should do the research about what CI/CD changes need to be made? Who should troubleshoot if things don't go as planned? Now, a natural candidate here would be the migration expert. Remember, my team was given near full allocation to this project. And although we know very little about these applications that we wanted to migrate, we would have the time and singular focus to gain deep knowledge about .NET Core and how to migrate to it. However, I cannot stress enough that we did not have context on these applications. Yes, all of our applications did have a rich suite of tests, to validate that behavior worked, but we just couldn't shake the nagging feeling that if we were to take this all on ourselves, it could not be the most efficient use of time, nor the safest course of action to have my team make deep fundamental changes to code bases we had never seen before. Okay, so then who should do the migration? What about those application experts I just told you about? Remember, I told you about them, those who feel ownership over an application and intimately know the code base? Well, they do have a lot of other things on their plate, namely shipping features to our clients, but they do have deep knowledge about how their applications work. Surely they must be more capable of making a fundamental change like migrating to .NET Core. However, we quickly realized that asking all product teams to do this migration would require so many engineers to spend the time to gain expertise in specifically the .NET Core migration. Not only would they never need this expertise again, but everybody would be doing this research in parallel and couldn't benefit from lessons that others had learned. And so 2 years ago, when we were pondering this question before we began, we wondered, okay, so how can we leverage the deep knowledge of our application experts about their applications, but also get the efficiency of having a dedicated team coordinating the effort? So we ultimately landed on a hybrid solution, sharing the responsibility between the migration and application experts. So my team signed up to do the legwork of the migration, doing all the upfront research, automating the migration, and being hands-on to troubleshoot. And once our work was done, we would provide step-by-step instructions on the automating script to our application experts. They would then schedule the migration around their existing feature work, run the scripts, and then validate that things worked after they made the changes. If you're watching this talk and you're planning a .NET Core migration or .NET 5 migration for your own company, and you're looking for a key takeaway from this talk, this is it. Making the migration a partnership between those that own the code and those with the know-how from research about the .NET Core migration was one of the keys that made all of this possible, that sort of split ownership. Because having dedicated migration experts gets you a lot of bang for your buck. Because there are a lot of similarities between one .NET application and the next. But even though they're very similar, there are differences. And so it's really great to have these application experts being able to close the gap and being able to go that last mile of the things that aren't necessarily standard. All right, so after we decided on this hybrid system of responsibility, we again edited our goal. So if our goal was previously to migrate all actively developed applications in our platform to .NET Core, we changed it to empowering product teams to do the same. So we did have one last decision to make. Should we break this migration into multiple steps, or should we do it all in one go? Well, answering this question ended up being very simple. At the scale that we were working with, especially with as large of an internal NuGet ecosystem as we have, remember we have 300 internal packages, it was not feasible to do this migration all at once. When I say all at once, what do I mean? I mean updating your web framework from ASP.NET to ASP.NET Core. I mean updating all your NuGet dependencies to be .NET Standard compatible. I mean updating your target framework to .NET Core. And I also mean updating your CI/CD pipelines to support all of the changes I just listed. Beyond the amount of research that would require to be able to understand all of these steps all at once, and beyond the infeasibility of teams having to set aside feature work for an extended period of time to do this all-in-one update, the crux of the matter is just that .NET Core is very different from .NET Framework. Much better, but very different. And so if you try to bite off too much at once, you're just kind of asking for instability. And doing this at an enterprise scale, if you work at a company, you probably understand this, that instability is just one of the things you really try to avoid in mature enterprise products. It's not something you want to sign up for. So our alternative was to chunk the migration into incremental and sequential phases. This would make the research burden on my team much more manageable. It would make scheduling the migrations easier for product teams. And the amount of instability would be capped, since each phase would only introduce a fraction of the amount of changes that a full upgrade would. So again, after making this decision that we wanted to go in incremental phases, We again updated our goal. Whereas previously, to empower product teams to do the migration, we switched it to empower product teams to incrementally do the migration. All right, so pausing for a moment, I do want to acknowledge that this decision that we made is not standard. There's very little to none of the literature, the blog posts, the official documentation really recommends or promotes this approach of splitting your .NET Core migration into phases. However, I do want to underscore that this insight for MasterCard, the thought that we could take this massive effort that seemed impossible and split it into what ended up for us being 5 releasable chunks, really is what made this effort tenable and possible for us to do. So yes, it was a great decision for us to have this insight. All right, so I told you that we split it up into phases. Now I want to kind of go through what does a phase look like, these 5 releasable phases. Well, first, we'd start with a manual conversion. Members of my team would pick applications and then set out to manually convert them. For example, in the phase upgrading to the SDK project file format, we would research that new CS proj format and just start experimenting with that application CS proj. And all the while, each of the changes that we were making, we would keep them in a log of each step that we took. And so next, we would translate that log into a link pad script that could replicate that same manual update. So every step that we did manually, we replaced it with the script. So depending on which phase that we were on, this might have involved using Roslyn to refactor C# code, or perhaps we would update some NuGet packages, or transform our XML or JSON configuration files, or we might just be moving files around. These scripts really, we tried to replicate anything that you could do by hand. Next, we did what we called dog fooding. So we would run the script on application that my team owns. So, i.e., that my team is the application experts of. I know it's a bit of a plot twist. We're both migration experts and application experts of some things. So since we were the ones that had deep knowledge of these applications, we actually felt like we had the confidence that we could monitor the success of the migration. And so we felt comfortable running these automated scripts on our own applications, and we feel like we could verify the behavior on the other side. And if we automated, if we ran the automation script and there was a little bit more left to do manually, we would take that learning and fold it back into the script, improving it and improving it with each application that we were migrating. And so after migrating a handful of our own applications, we released our migrations to what we called our fast track teams. So let me explain. Most of you probably work with some developers who really like using like the nightly build of Firefox or like their favorite IDE, or they'll seek out like the release candidate versions of things like .NET 5. So we found entire product teams like that, people who really like being on the cutting edge. And so they volunteered, and we would then migrate their applications. And then similar to that dog fooding step, when we migrated the applications that my team knew and intimately understood, anything we learned from these fast track migrations, any manual steps left over at the left at the end, we would take those learnings, fold them back into the script, improving it with each application that we converted. And so now by this time, we would probably have deployed all the way to production these changes on 10 to 15 applications. And so we would have enough confidence that we could roll out to the other 150 web applications, let's say. And so we could release and then follow up with any teams that had, follow up with teams to make sure that they are keeping up to date. All right, so this is what a singular phase consists of. It's kind of this increasing release in these concentric circles, building our confidence with each and every stage we released, and making sure that our automations worked for everybody. All right, so if this is what each individual phase looked like, let me briefly discuss what our phases were. So like I said, we ended up with 5 phases. The first was to upgrade all of our third-party NuGet dependencies to .NET Standard compatible versions. The second, updating to the SDK project file format. The third, updating our web framework from ASP.NET MVC or ASP.NET Web API to ASP.NET Core. The fourth, updating internal NuGet packages to target .NET Standard 2.0. And then the fifth and final one, switching our applications to target .NET Core. So by step 5, we had made it. Great. So now I want to spend some time going into each of these phases. I'll be brief, but I am going to be a little bit more technical, talking about these phases. Specifically on each of them, I'm going to touch what the benefit of releasing this incrementally was, so what a team could expect to get out of doing this update, and then also talk about what work was required to be able to release this, this phased update. So the first step was to update our third-party NuGet packages to .NET Standard compatible versions. This may be easier for other companies. Ended up actually being fairly simple for us because we only had two dependencies that really needed updating: AutoFac, which I love, which is our dependency injection and version of control library use, and NUnit, which I also love, which is our unit testing library. The incremental benefit of doing these updates was that we got to use the new features of AutoFac and NUnit. It did require actually a surprising amount of work because of our internal NuGet package situation. We have a lot of libraries that build off of either AutoFac or NUnit, so we needed to update those internal libraries to be compatible with these new major versions of AutoFac and NUnit. We also wrote a script to refactor the C# around the breaking changes that these libraries had. And we also needed to update specifically our test runner to support these new versions. So depending on your situation and how up to date you keep your third-party dependencies, you might be able to completely skip this step. But this is what it looked like for us. Our second phase was updating to the SDK project file format. This, I think, has a couple of other names. You might just know it as the new project file format. But this one was actually really easy to sell to teams because it's a much simpler package management model because everything is just controlled through your package references and your CS_proj file. And because you don't need to list every file anymore in your CS_proj, you had way fewer merge conflicts. So teams were very excited about this. The work that was required here is we did have to do quite a bit of research on how to properly set this up for ASP.NET applications. And so it's a lot of trial and error just to make sure that we were getting the same things being deployed and all of our, things that set IIS settings were being properly set in the new, shorter, sleeker project file format. All right, and then we also wrote a migration script that would transform your CS_proj from one to the other. All right, the third one was gigantic. It was so big. It was updating your applications, your web applications, if you have them, from ASP.NET to ASP.NET Core. This one was also pretty easy to sell, mostly because you didn't have to use configure way to false anymore. People loved that. But you also got the full ASP.NET Core feature set. This one did require a lot of work. Specifically, the team that wrote ASP.NET Core took the opportunity to kind of come up with a lot of new and exciting APIs and ways of doing things. So for instance, previously, when you used to return HTTP code, HTTP status code result, like 200, you can now, from your controller, you can just do this.ok, which is great. That's my favorite API, this.ok. But there are all these kind of, some of them larger, some of them kind of small and trivial like that one. These new patterns that we wrote a migration script that would detect if you're using quote unquote the old pattern and shift you to the new ASP.NET Core compatible version. So this ended up being a very long migration script. It just had a lot of cases of switching over between APIs. And similar to that first phase, we needed to release New versions of our internal libraries, because we had a number of libraries that built off of, Web API or MVC specific things. Specifically, we previously, would set up per request behavior using an HTTP module, but we needed to switch that into, so that would work in ASP.NET. But for ASP.NET Core, you need to switch it to middleware. So these were the kind of changes that we needed to make to a lot of our internal libraries. And then also ASP.NET Core deploys completely differently than ASP.NET. It is an executable that you kick off rather than a DLL that works through DLL magic. So we needed to change our deployment pipeline to get that support. The fourth phase was updating all of those 300 internal NuGet packages to target .NET Standard. In most cases, this was very simple. Basically a one-line change, because .NET Standard, especially 2.0, is very compatible. But we did actually take this opportunity to multi-target some of our packages, so target both framework and .NET Standard, because this allowed us to drop some legacy APIs without doing a major version bump. So things we didn't really want to support anymore, but still maintaining compatibility for all of our .NET Framework consumers. This was a big thing that we really tried to design into our migration, is that we didn't want to leave anyone behind. If you stopped on a certain phase, or you were some legacy code and you just weren't going to join us for any of the phases, we didn't want to block you out from, even consuming our internal packages. Like if they had a bug fix, or performance, a version with better performance, we didn't want to say, no, you can't update unless, unless you come on this road with us. We wanted to ensure compatibility for any and all applications, regardless of whether they were legacy or had made other decisions. Great. So this, as I alluded to, did require quite a bit of work, because we did need to convert all of our libraries to target .NET Standard 2.0. The migration script was super easy. It was basically a dictionary. If you have this library installed, update it to this new version. And you know where that leads us. I told you there were 5 phases. We ended up at .NET Core. So this is updating all of our applications to target .NET Core 3.1. This is the easiest update and gives you the biggest benefits, because you get .NET Core performance, you get .NET Core features, and you also get a feeling of accomplishment. And the work required is very small, just some minor deployment changes, because you had laid so much of the groundwork in your previous phases. But the actual code changes required here for a consuming team are very, very small, mostly behind the scenes effort. So those are the 5 phases we ended up with. As I alluded to, you may have more, you may have less, depending on where you, depending on kind of what your internal ecosystem looks like. 5 is just what worked for us. All right. So I spent this talk really emphasizing the strengths of our approach. That was strength 1, that splitting the responsibility between migration experts who create a standard solution and application experts who complete the last mile. That was a strength of our approach. Another strength was that we split up the project into manageable phases that could be independently developed and released. And then the third strength, I really think, of our approach was that we designed each of these phases around ensuring quality by releasing it in those series of concentric circles, wider and wider, building confidence with each group that we release to. So we could be sure that by the time we release to all of our applications, and more broadly, that we were putting out a pretty good product. So I've covered those 3 strengths, but I did want to just dwell for a few moments, our last few moments together, on some of the things that didn't go as well. I'll be candid about these. So the first is that incremental updates are just intrinsically less motivating. If you release in too small of phases, product teams don't really feel like they're getting too much out of each update, and they can just get update fatigue. So our solution to this was bundling in extra features into the phases, to make them more interesting. So we added on extra things that we didn't necessarily need to. And this one I also felt kind of bad about is that we had this idea that we could get you 95% of the way there. The fact is we just couldn't. Although .NET applications look very similar, if you're innovating or if you're an older application that uses patterns that have kind of fallen out of favor internally, we could get, the middle of the bell curve to 95% of the way towards a migration. But if you were on either end, sometimes it felt like we were only getting you 15 or 20% there. We did mitigate this once we realized this problem by adding some of these teams that had particular challenges to our fast track teams so that we could be sure before we did our wide release that we made solutions that worked for them. And then the final one is that the incremental approach is not super supported by tooling. If anyone from Microsoft is listening, feel free to reach out to me. I can provide you with some examples. There's one on the screen. But this did mean that we spent a little bit more time implementing workarounds to maintain the developer experience. So what we really didn't want was to release a phase and then tell people, this is 2 steps forward, but really also 1 step back. And so this was something that we had to work with. Great. So I just want to thank everybody. Thanks for joining me and listening to this story of a massive and messy migration. Like I said, it's been a joy and privilege to work on this for the last 2 years. This has been so much fun. I've learned a bunch and gained a lot of appreciation for all these technologies and just the hard work of the .NET teams at Microsoft. And so I do love to hear from folks. Please don't hesitate to reach out to me if you're thinking of doing a migration of your own and want to ask more specific questions.
That was amazing, Lizzie. That was incredible. I loved hearing about that. I've worked on some migrations before I worked at Microsoft, and now, and you touched on so many things and pulled it all together so well. I loved how you talked about the hybrid shared responsibility. And I loved also, honestly, when you talked about some things that don't go well, I feel like those are things that I communicate with teams at Microsoft that work on documentation, and I will definitely give them some of that feedback. So, I mean, it was just, I'm blown away. Some things, some good questions here. One that came up was talking about third-party components. And you talked about some libraries. Did you run into some components that just were not going to be compatible?
Honestly, there were very, very few. There was some kind of just utility libraries that we just weren't able to bring with us. Maybe, I don't know, things around like file upload or file parsing. We just honestly had to find a different library that had been more recently maintained. So there were a couple instances, but we were very lucky that we didn't have any like deep dependencies on those.
Okay. I had one other question here. There's working with microservices. So you were talking mostly about kind of separate applications and NuGet packages. Did you deal with services, and did you have to work with managing microservice migration as well?
Yeah. So one thing I kind of wanted to address at the end of that question about just doing new development so like with microservices, right, you can just spin them up. And so you could just spin up new ones in .NET Core.
Yeah.
But just kind of the reality of the work that we do is that we have a lot of long-standing products that are seeing tons of development every day. And so it felt like, yes, we could just, like our new products, we could spin them up. We just have hundreds of engineers that are working in these other products. And we want them to be able to capture all the goodness of .NET Core and ASP.NET Core. So we briefly considered that, but we just work on existing products more than we spin up new ones sometimes.
Totally makes sense. We've got some other good questions coming in on Twitter, but we're at time, so we'll have to move on to the next one. But thank you very much. That was a really phenomenal presentation.
Thank you.
Thanks, Lizzie.
Yeah, thanks everybody.
All right, we've got another one. They're action-packed today. We've got so many great talks. The next one is from Ed Charbonneau, and he's going to be talking about testing with Blazor. And so you're talking about all the different kinds of testing, right? Integration and unit testing, and there's one other one. And I'm excited to see what you have to say here.
That's right, John. We're going to cover all the testing that you could possibly imagine for Blazor. We're going to do some unit tests, component tests, integration tests, end-to-end tests, you name it. We're going to try to fit all that in 30 minutes.
Awesome. All right, let's go.
All right. Give me 1 second here, folks. Let me get this, make sure the screen's up here where it's supposed to be.
Yeah, and Ed, you're a little bit quiet. I don't know if you can boost your gain at all.
Let's see what I can do for that here. Let's see. We didn't catch this in pre-show. Let me know if that's better.
That is better.
All right. So we're going to talk about bulletproof Blazor applications today. We're going to talk about stability testing. We've got a lot of testing tools to talk about, so I'm going to try to go through this fairly quickly. I have some demos that I'd love to get to. .NET developers love to test. That shows with the fact that there are hundreds of millions of downloads of the XUnit library that we'll be talking about today and some others. So if you're looking at building a Blazor application, you're looking at the kind of the landscape of what's been developed over the last couple years of Blazor and all of the cycles that we've gone through with Blazor all the way up to .NET 5. You're probably wondering how testing fits in to all of that ecosystem. So Blazor, in my opinion, is actually very inherently testable. One of the big reasons behind that is because it is full stack .NET. It's C# from end to end. So we can use our Blazor, we can use our testing tools that we're used to test not only the front end, but our shared and back-end layers as well. Also, Blazor components themselves are just .NET classes, so there's a lot that we can do around testing components in Blazor. And Visual Studio integration is absolutely wonderful with unit testing in general. So we have that right out of the box for our front end of the application where we're not used to having all of that power. So we're going to talk about testing it all today. We're going to talk about unit testing, some integration testing, and we'll even cover some system testing. There's a lot of tools out there to do these things. For unit tests and integration tests, we can use things like XUnit. We're going to use BUnit today. This is a new framework that I'm going to be talking about. And if you're doing system testing, Selenium is a choice that you could use for doing system or end-to-end testing. It's very popular with the open source community. I'm also going to talk about something a little more closer to what I work with. I'm going to talk about Telerik JustMock and how it relates to Telerik UI for Blazor, because we have a nice integration story that's starting to happen here around the Telerik products. And that brings us to Telerik Test Studio. That gives us even more leverage for system testing because it has that tight integration with Telerik UI for Blazor. So we get this nice spectrum of testing with all of our Blazor tooling. So let's start with unit testing. I like unit testing because of the red-green refactor methodology. This comes from the test-driven development aspect of unit testing. And what's nice about the red-green refactor pattern here is that we can iterate quickly through our application code without running the entire application. So we can focus in on a small unit of our application, run tests on it, and then we can also refactor and rewrite parts of that code with confidence because we have tests that signal to us whether they're working or not. And when we're talking about Blazor, what's nice is with XUnit, we can cover the entire application with tests with XUnit. Any kind of core logic that doesn't rely on creating some sort of markup or UI, we can test with XUnit. So we can test application logic, shared libraries, shared component logic. So we can use it on our client, our server, and most importantly, our shared projects within our Blazor application. If you're not familiar with XUnit tests, this is a little overview of how they work. First of all, we identify the method that we're going to use to test our code with a fact attribute. So we'll say this is our unit test, and in this example, we're going to say, can it validate a correctly formatted email address? And we'll arrange our test, maybe new up the unit under test. We might have some actions that we need to perform on that, and then we'll validate the outcome of that test. We can carry that further into a Blazor application with the addition of a nice testing library called BUnit. So this is a Blazor component test library written by a gentleman named Eagle Hansen, a Microsoft MVP. His information on Twitter you can find on the bottom of the slide there. And what makes BUnit unique is it's a Razor component testing library, and it lets us use either C# or Razor syntax to write our unit tests. And it has a semantic HTML comparison tool with it. So when we write our unit test for our component, we might render some markup, and we want to make sure that markup is correct. But we don't want to be bothered with things that don't really affect how that component gets rendered in the browsers. Things such as white space or the order of class attributes that are attached to that. So we get some added benefit here. We're not doing a straight string-to-string comparison. We have this smart semantic HTML comparer. Another thing is we can interact, inspect, and trigger event handlers in components. So we have the life cycle of the component understood by the test framework. So let's take a look at what a unit test for a BUnit test for a Razor component would look like. It looks awful similar to an XUnit test because it's actually leveraging the XUnit library. You can also use other test unit libraries with it, but I'm using XUnit with it. So we're going to test to see if the initial rendering of a component is valid and what we expect. So the first thing we'll do is we'll tell BUnit to render that component, and we're going to render an alert component. We'll set up the rendered HTML of what we expect that to be. And again, this is a semantic comparison, so white space and things like that aren't necessarily going to matter here. So we have a div element with a button inside. We're going to make sure that it has the correct classes on it and everything, and that would so that it would render in the browser appropriately. And then finally, we'll just check with a nice extension method here and say, did the component render correctly? Does it match the expected markup? What's nice about this is Blazor doesn't have a hot reloading mechanism yet, and hot reloading is a nice feature, but this is an even better feature in my opinion because I don't have to reload my entire application and visually test components myself to make sure they're working properly. So this lets me isolate that component in a unit test and rapidly test it. So let's take a look at a demo here. We kind of walked through some code, but let's see how it actually looks in Visual Studio when we're doing these type of tests. Now, real quick, let me run the application just so you can see what it looks like. And what we're focusing on is this alert box up here. So we have a unit test that defines whether it rendered correctly. I also have a dismiss button on here. I'm going to go ahead and click that. The dismiss button's not working for some reason. Let's go into our application and look at our unit tests and see what's going on here. So I'm going to open up Test Explorer. And in Test Explorer, you'll see I have multiple tests running here. A lot of failures. We're going to go through and fix a lot of these. Right now, we have our initial rendering test that passes, so we know the alert component renders correctly the first time, but the dismiss button isn't working, and there's an info theme that's not being applied. So if we go over to our is the alert dismissible test, notice the output that we get from our unit test window. So BUnit has done an HTML comparison that has failed. So we've got some feedback here. And it has a couple errors that are being listed. It's missing a button and a div element that it expected. The next thing we can look at here that's really nice is we have an actual HTML that's expected, or the actual HTML that was rendered, and the expected HTML. So what's happening here is the unit test is clicking the close button, and it's expecting a different display to come up with the close state of that alert box. However, when it clicks the button, it still has the same rendering as it did initially. if we look at our unit test, this is the unit test that's failing. We're rendering an alert box. We're expecting an open button to be displayed to reopen the dismissed alert box. We're clicking on the close button, and then we're comparing the markup to see if it shows the open button now that the close button has been clicked. So I'm going to go back to my alert page, or my alert component here. And I can see I have an if statement that checks a flag to see if it's hidden or not. And I've purposely kind of left this little clue to myself that we forgot to set this flag properly. So I'm going to switch this from true or false to true now, so we hide it appropriately. And I'm going to go back to my test explorer, and I'll just rerun this one test. So instead of running the entire application, finding the page that that component exists on, and clicking through to see if it's rendering correctly, I can simply just run a unit test, and now that test is passing. So we've got another test that was failing here. We have an info theme that's missing. So the alert box has two different types of themes. It can be a red alert box, or it can be a blue alert box, depending on the flag that is set to display one theme or another. And this test is written a little bit different. Instead of setting the expected markup and checking if all of the markup on the component renders correctly, on this one, we're going to pass in a parameter to set that component's info style to true. And then we're going to see if the CSS values on that component are rendered correctly. So we're expecting it to be a CSS value of alert-info. And then we're going to render that component, and we'll find the outer div on the component and get the class attributes from it. And then we'll assert if the expected CSS matches the actual CSS that was rendered. So we don't have to open the application up and run the application to see this in effect. We can go back and make a fix here. I've got my alert dangers hard-coded and static here. So I'm going to remove that line and replace it with a working copy that has a class that has a data-bound CSS alert attribute that properly displays the correct theme when the flag is set. So I'll go back to my unit tests, and we'll rerun this one. And now we'll get a passing unit test here. So what's nice is I get definite feedback. It's telling me that this CSS class was invalid. We expected an info theme, we got an alert theme, and now I'm able to fix that very easily, and I don't have to, again, rerun the browser or the entire application to find out what's happening. Next, I'm going to open up some integration tests that I have. If we look back at the page that we were testing, I've got an entire form here. And the form has several inputs, a birth date text box, first name, last name, email, and I've got a couple drop downs here as well. So my drop down for my region and my team, they're showing no data. So this hasn't been correctly implemented yet. There's something going on here that I need to check my tests for. And I see I've got 3 failing unit tests here. Let's see what we've got with this first test. So what should happen is when the page loads, the index page loads, it should load some data into those drop downs and set the default value for us. Now I've got a kind of an odd exception here. It says can't provide a value for the property data service. For the property data service on the type of index, there's no registered service type for iData service. So when I have that message, cannot find a registered service for a type anywhere in Blazor ever, or in ASP.NET, a matter of fact, means I haven't registered a dependency with dependency injection properly. So let's talk about how we can resolve that. We've got some slides here that'll help describe the scenario that we're looking at. So we can do some more integration style testing with BUnit. I've got some third-party components from Telerik that I'm testing. I have some outside services that need to be injected into the component for it to work. There's a lot of different things working together here. I want to check some interactions between different components. So we're going to do a little bit more of an escalated test than just a unit test. What's nice is with BUnit, we can pass in parameters, we can accept cascading values, we can inject services as if it is an entire Blazor application running. And we can use those with our component under test. For this, I'm going to use some mocking. We're going to mock the IJS runtime. We can mock authentication and things like that as well. And for mocking, I'm going to use Telerik JustMock. There's other mocking libraries out there, but what's nice is we're looking for integration points with Blazor right now, and we're finding that BUnit is a nice fit for JustMock when we're using the Telerik UI components. So with JustMock, we're able to replace objects and simulate real ones. That lets us isolate on the code that we're testing and focus on the unit under test. And best of all, JustMock's free. You can get JustMock. JustMock Lite is a free version of JustMock from Telerik. So what is a mock going to do for us? Remember, we had that error that said that we can't inject it, or it wasn't able to find the iData service instance. With JustMock, we can set up a mock of that iData service and control its outputs. So the first thing we'll do is we'll say we want a new mock service. So we use the method mock.create, and we simply pass it iData service. And the JustMock framework will fill in the blanks for us. We don't have to create a special concrete type. We don't need a fake service to inject into our component. We can just say mock.create and give it the interface that we want it to create an instance for. Once we have that instance, we can even define how we want the methods on that instance to behave. So I'm going to take my mock data service, and I know my component calls the getRegions method. And I'm going to tell that getRegions method to pass back a static list of items instead of going out to the web or maybe a database or something like that and pull in data there. So let's look back at our demo and go over to our unit test and see what we have. So I've got my mocks already set up here, so you didn't have to watch me hand code those. It's exactly the one that you saw on the previous slide. And then in BUnit, we can tell it to add our services just like we would in a Blazor application. So I can say services, add singleton, add my mock data service. And I'll go ahead and uncomment my line of code here that initializes all of those services for us. Let's go back to our unit tests, and we'll give that one a run. What's nice is I can run just the failing unit test that I'm focused on, and this gives me a nice development cycle, so I don't have to keep reloading that entire application or waiting for every unit test to run. So we have an assert failure, and we expect that the default selected value should be readBB for this test. So let's go over to our component, our index page, and look at what's happening here. So to move this along a little bit quicker, I'm going to go ahead and fix all of those errors that we see. On our initialization of our component should be loading those values from the data service. And it should also select the default item for that first item on our data, for our drop-down list. And then when it selects that item, it should populate the cascading drop-down that's beneath it. So we're going to load that component, we're going to select the first item by default, and then load the following cascading drop-down as well, and select its first item. So I'll save this, and I'll go back to Test Explorer, and I'll go ahead and just run all of my form tests now. And again, I don't have to open up my application and exercise drop-down boxes manually to see if these things are working. This unit test is going to do all of that for me in a nice isolated fashion. And now you can see all of my tests are passing, and I didn't have to open the application once. But if we wanted to go back now and see the application working properly, first of all, I have my dismissible button or alert box. I can close it and reopen it. So that's working now. And notice my drop-downs actually have data now because they're actually calling the method that they're supposed to call and selecting the default items that they were supposed to select. I have one more feature on this page I want to test here. If I submit this, you'll see I get a thank you pop-up. So I have one more set of tools that I want to show because I want to talk about system testing. So we're going to evaluate a complete integrated system here. So we're talking about automated functional testing for the end-to-end system. And I'm going to use Telerik Test Studio for this. It's got some really advanced features that are going to cut down the time for developers to create these tests. And there's also tooling that's bundled with it that allows your QA team to create tests as well, and they don't even need Visual Studio to do that. So we have this really advanced test recorder that's bundled with Test Studio, and it has Telerik UI for Blazor integration built into it. So it can identify the Telerik UI components that are in a Blazor application and offer some contextual awareness to the person creating the tests. And this is what Test Studio looks like. I'll give you a live demo here in a second, but this is the Telerik UI for Blazor integration that we're talking about. It will actually find the component on the screen and highlight that component in purple and let us quickly create predefined tests for that. So let's take a look at one more demo. I'm going to open my Solution Explorer where I have a Test Studio test that I'm going to start working on. Right now the test doesn't have any steps in it. I have this recorder button up at the top left-hand corner. Let me zoom in a little bit so you can see the toolbar here. So I can record tests and I can play back tests. And there's some other advanced features here as well. We're not going to focus on those today, but I'm going to go ahead and hit record. It's going to ask for a URL, and this URL could be my application that's running on a test server or the full production application. I'm going to hit record, and we're going to go through and visually build a test together. So I can come in here and I can exercise any of the components, and I can inspect their state and their values. For example, if I hover over my Telerik input, my Telerik date picker, I can get this nice contextually aware builder that knows this is a Telerik UI component. This works with regular HTML components as well, but I get additional feedback from the tool because it is a Telerik component. So I can easily verify that the default date is 1980 on this component. I lost my recorder there for a second. So let's try that again. All right, I lost that one. Let's test and see that our drop-down list is by default the first item on that list. So we'll go ahead and extract that. We'll do the same for this one down here. And then we'll submit the page. And when we submit it, we'll check that we got the thank you page. So we'll go ahead and check this element here. And we'll verify that the element is contains the text thank you. And we'll make sure that the test or the response here is thank you, we've received your information. There we go. I'm not being still enough with the mouse is what this is. So I can see that the message contains thank you, we've received your information. And let's go ahead and make sure that our close button is visible as well. So we want the user to be able to close that element out. Now I'm going to end this recording session. And I'll close my browser, and you can see that in Visual Studio, I have all of those steps that we just recorded. Now I can go back and replay this and execute that test. So I'm going to hit the play button here. You'll notice my browser pops up. This is completely automated now, just so you can tell I don't have my hands on the mouse. I'll hold them up here in front of the camera. And the test studio is going through and testing all of the elements that I interacted with and testing the values for those items. So now you can see it's clicked the submit button, it's pulled up the thank you element, and it's inspecting that element. Now some of the waiting times here can be adjusted. They might be a little bit long. Since we're dealing with a single page application, there's some awaits built in to make sure that the single page application is responding correctly. You can adjust those up and down as needed. And now you can see that all of my tests for that recorded test have passed. So we've got 8 tests that have been executed and passed. And if I need to come in and edit any of these tests, for example, my test that tests the thank you message, if that thank you message changes, I don't have to go back and re-record the entire test. I can come in here and just set the expected string. What else is really nice about Test Studio is that these are C# code files that are generated by the recorder. And if I wanted to hand code these or go in and edit them in C#, they are .NET and C#. So we've gone through, we've done unit testing, we've done some integration testing, we've seen how Test Studio can help us record automated unit tests or automated system tests, and I think that Blazor is a very good platform for all of these testing capabilities. You can really move a lot quicker, in my opinion, if you're using some of these tools instead of doing the manual reloading of your application to check things. So you can find all of the tools I used today at the following URLs. I also have an article at the bottom linked here that you can go through and read through a written version of the presentation that I gave today. If we have time for questions, I'll be happy to take them. Otherwise, I can go on Twitter and answer those, John. Not hearing you, John.
Whoop. Thanks a bunch. Can you hear me now?
I can hear you now.
Awesome. I think we have time for just one quick question. So you talked about all the integration, unit, like all different types of testing. Have you looked at performance testing, and especially like automated performance testing?
Test Studio can handle automated performance testing. It can do load testing, API testing, has OCR verification.
Wow.
There's some really advanced features in there that it's just too much to cover. We did just do a webinar. So if you go to Telerik.com, sorry, the YouTube page for Telerik, YouTube/Telerik, you can find our latest Test Studio webinar there. And they went through some more detailed demos of Test Studio on that webinar.
Very cool. Thanks a bunch. That was amazing. Really appreciated it. Okay.
Appreciate it.
All right. So goodbye, Ed. And I'm happy to welcome up next. We have Brian Hogan, and Brian's going to be talking about building resilient applications with Poly. So
hello. Hey, John.
Take it away, Brian.
Thank you very much. As John said, my name is Brian Hogan. I have been using Poly for quite a few years and writing about it and occasionally presenting. And today I'm going to give you a quick overview of the whole lot of the resilience framework. Oh. Failures happen. They can happen anytime to any application, and they will happen to your application. What do we do about it when something goes wrong? Many of us work on applications that rely on connectivity, but connectivity has never, ever been a guarantee. We have to deal with software failures, local network outages, and of course, an unreliable internet. Any problem along the way, and it could lead to your request failing. For applications such as mobile applications or IoT or embedded systems, this is especially true. So what will your application do if there's a transient fault or a longer outage when making a request to a remote system? Will the whole thing grind to a halt, or will you lose just that one request? For a lot of applications, losing a single request might be fine. But for critical applications, think of medical, financial, losing a single request can be quite serious. What could you do about it? The obvious answer is to retry a request. So think of your local system making requests to remote systems. Make a request, get back a failure. Retry it, get back a failure. Retry, failure, retry, success. So keep retrying until you get a response. Keep retrying within reason, not forever, of course. So how might you program up something like that? If you're using HTTP client, you'll have a get async hitting a remote endpoint. You might put a for loop around it, which specifies the number of times to retry. You'd have a catch looking for exceptions. And then you might have a break to get out of that loop when you have a success. I've had people at conferences tell me that this is a fine approach, but from my perspective, it's fragile, be very hard to use in multiple locations, hard to change, hard to configure, hard to customize. And of course, we're here to talk about Poly. Poly is a resilience framework for .NET, and if you're working in Microsoft, as I imagine most of us are, it's really the only game in town. If you have worked in Java, you've probably come across Hystrix. Poly helps protect your application from failure, but it has a knock-on effect on upstream and downstream applications, helping them to remain stable also. With Poly, you can handle all sorts of failures. Poly helps you to do this through what are called policies, such as retry, wait and retry, circuit breaker, and a few more. Poly was started in 2013 by Michael Wolfenden, but more recently it was taken over by the AppV Next group with Dylan Reisenberger as the lead architect on the project. Poly is active on GitHub, Slack, they have a blog, and it's getting about 150,000 downloads per day. Dylan has been on my podcast and on .NET Rocks. Over the last few years, the popularity of Poly has soared. When I started working on Poly, it was something like, I remember 10 to 14,000 downloads per day. Those are the numbers I remember, and now it's at 150. As I said a moment ago, Poly works on all .NET platforms. So again, think of how this might help you with mobile applications, embedded devices, or IoT, where connections are more tricky. For those of us who may be working on technology that's pre.NET Core 2.1 or .NET 5, a request with Poly would look something like this. You have your HTTP GET, and it's wrapped inside a policy. The policy is defined like this, where you say it handles a HTTP response message looking for a success code. If you don't get one, or if you get an exception, you should perform a retry. That's pretty good, relatively easy. But since .NET Core 2.1, this is all you need at the point of execution. There's no sign of Poly, there's no sign of the policies. It is your familiar and traditional HTTP GET, and you get a HTTP response. You don't have to unwrap it, you don't have to do anything with it. You don't need to pass the policies around. This is thanks to the HTTP client factory, and I'm going to talk about that a little bit more in a few minutes. When I started working with Poly, and when I started working on the Pluralsight course for it, I looked to see if there was any definition out there of a resilience framework, and there wasn't, so I came up with my own. From my perspective, a resilience framework actively protects resources, restricting the amount of memory, threads, and sockets that an application can use. When possible, it will let you recover from a failure through something like a retry, and if recovery is not possible, it will facilitate graceful degradation. Now, what graceful degradation is very much up to you. It might mean that you fail quickly rather than slowly, or that you reduce load on remote systems, or potentially shed load on your own application. And again, all of these have a knock-on effect of helping the services that you depend on also, by not overloading them if they're stressed, giving them a break, giving them a chance to recover. At the heart of Poly are policies. These are things such as a retry, timeout, and circuit breaker, and I will get to each one of those in turn. A policy is made up of two parts, two clauses, let's say, the handles clause and the behavior clause. The handles clause specifies the failure the policy should respond to, like a 400, 401, or some type of exception. And the behavior clause specifies what should be done. In this case, retry 3 times. As you can see here in a fluent style. They're reusable. A single policy can be used in multiple places and will not interfere with another use of that same policy. They're thread safe. It is no problem at all to use the same policy at the same time in multiple places. Each policy can execute a delegate to perform an action before the behavior clause kicks in. So think of the example of a reauthorization. There's not much point in retrying a request that failed due to reauthorization unless you do something to fix that authorization issue. And I'll show you that as well in a sec. Poly supports synchronous and asynchronous requests. And finally, you can wrap policies. So the idea would be you'd have a HTTP request with a retry policy around it, with another one like a circuit breaker around that, and then potentially a fallback around everything. Poly policies are broken into 2 broad categories: the reactive strategies and the proactive strategies. The reactive strategies are made up of the retry, wait and retry, circuit breaker, and fallback. These respond to problems that have happened. Proactive strategies monitor ongoing events and attempt to prevent problems from occurring, and they stabilize the system or potentially allow you to fail gracefully. And the proactive policies are timeout, caching, and bulkhead isolation. I will go through each one of those in turn. To give you an idea of where Poly sits and how it works when it's interacting with a request, I'm going to go through the example of a retry policy. You make a request, Poly checks if it was a success. If it wasn't, Poly checks whether or not it should perform a retry. If it should perform the retry, it will make that request again. Poly will then check again if it was a success. If it was, it will return you the response, the HTTP response that you would normally expect. If it was not a success, it will check again whether or not it should retry. And if it should not retry at this point, you've, let's say, used up all the retries that you were going to make, it will return a response, which will be again a HTTP response indicating failure. Poly doesn't interfere with the flow of the request. If it succeeds, Poly doesn't do anything. If the request fails and should not be retried, Poly doesn't do anything. With a retry policy, you can make hundreds of requests using a single policy and they will not interfere with each other. Making a request inside a policy has very little impact on the speed of that request, and the Poly team have been working on that over the last few years to make it even less of a performance issue. With regard to retry, there is one problem with it. When you send your request and it fails, you will retry immediately. When that comes back with a failure, it will retry immediately again. So if you're calling a system that's failing because it's already overloaded, you're not helping by hammering it with more requests. You're also making life much worse for yourself because you're opening up potentially more sockets, more threads, more memory in use. What would be better would be to give that remote system a chance to recover. And that's where the wait and retry policy comes in. When you make a request, if it fails, you pause and then you retry. If that one fails, you can pause a little longer and so on. And you can choose any algorithm you want to calculate the period between retries. This gives the remote system a chance to recover. For anyone familiar with networking protocols, Ethernet uses something like this when there are packet collisions. If you are making multiple simultaneous requests using the same wait and retry policy, they could all potentially back off and retry at the exact same time. And that's not good because you're going to have a burst of requests hitting the remote system at 2 seconds, at 6 seconds, at 14 seconds. So you can add a little jitter to that delay calculation function. So it helps randomize when the retries happen. Here's what a retry looks like. So I showed you a little earlier. It says handle HTTP response messages, and if it's anything other than a success code, retry 3 times. And then this is what a wait and retry looks like. Again, it's the same handles clause, but now it says retry up to 3 times, but here's a way of calculating the delay between the retries. And again, you can use any calculation you want. I mentioned reauthorization because it's a more interesting case. There's not much use in retrying the exact same request if you're getting an unauthorized error. Instead, what you do is you use the onRetry delegate as part of the policy. So the policy at a high level says if it's not a success code, you should retry. And then specifically within the retry, prior to executing the retry, this block is hit. And if the status code is unauthorized, you perform some custom reauthorization logic. That might be going out and getting a new JWT or a new cookie or whatever it happens to be. One drawback on this one is if you try to do this with a HTTP client factory, it is more complicated. But I have some examples on my blog for that one. One thing that I've been asked at conferences was, can Poly be used for non-HTTP requests? And it can. You can pretty much use Poly when calling any method, whether or not it returns something. So here are a few examples. Here I'm checking the result coming back, that's an int. I'm checking if it's not 0 or if there was an exception, retry 3 times. And here I'm executing it. In these examples, you have to execute your code explicitly inside the policy because you're not using HTTP client factory. A relatively straightforward example. I have a enum of type job status, and if the response is not valid, I'm performing a wait and retry. And with this one, I'm simply saying if an exception is thrown when I call this code, retry up to 3 times. So that's the retry and wait and retry policies. Another policy is the fallback policy. It's usually the last one that you would use when you're executing a request. So you might have a retry, and then outside it would be a fallback. You can return some sort of default value when everything else has failed. Fallback also supports a delegate that allows you to perform any action you want. So maybe you will page someone or restart a service or scale a system, something like that. And its code looks like this. In this case, I'm checking if the status code I got back was an internal server error or not. And I'm generating a whole new HTTP response message to return instead of what I was expecting to get from the endpoint I was calling. The next policy is a circuit breaker. So this is quite like the circuit breaker in your home, or in some countries, they're referred to as trip switches. It cuts the connection when a problem is detected. Circuit breaker has 3 states. The closed state is the normal operational state. Closed like an electrical circuit, current flows. In our case, requests flow. Open, no requests are flowing. And if a caller makes a request via something protected by a circuit breaker, they will get a broken circuit exception immediately, no delays. And then finally, there's a half open status. This is a sort of test status. When a real request is made and the circuit breaker is in half open, if the response comes back from the remote system as a success, the circuit breaker switches to closed. If not, it switches back to open. I'll show you all this in a state diagram in a moment. There are 2 kinds of circuit breaker, the original circuit breaker and an advanced circuit breaker. The original one will open if there are some number of consecutive failures. So 2 failures in a row, 3 failures in a row. The advanced circuit breaker opens if a percentage of failures occurs over time and there's a minimum throughput. And I'll show you 2 examples in a second. But to make things clear, a circuit breaker starts in a closed state. If there are problems, it transitions to open. After a period of time being open, it will transition to half open. If a request fails during half open, it transitions to open again, stays open for a period, moves back to half open, and then if that following request works, it moves back to closed. And again, just to hammer the point home, when the circuit breaker is open, it immediately returns exceptions. Again, not using up any resources on your application, not holding threads, not holding memory, not holding sockets. If my application is connected to multiple remote applications and each has multiple endpoints, a circuit breaker could be used to protect a single endpoint, a group of endpoints, or, unlikely the case, all outbound requests. I mentioned that there are 2 kinds of circuit breaker. This is the original one. It says if there are 2 consecutive errors, break the circuit for 60 seconds. On break, on reset, and on half open are delegates that you can use when the circuit breaks, when it's closing, and when it's in a half open state. You could use it for logging or other purposes. The advanced circuit breaker says if 50% of requests in a 30-second window with a minimum throughput of 7 requests have failed, so half the requests in a 30-second window have failed and you've had at least 7 requests, then break the circuit for 60 seconds. So this allows you to add a little more nuance to breaking your circuit. The circuit breaker I showed is fine if you have a single instance of an application, but if you have multiple instances, for the circuit breaker to function correctly, all the instances of your application need to share the state. How many times have you had a request that failed? And that's where something like Azure Durable Functions or Azure Durable